So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Is a supernova, first of all?
A supernova is an exploding star.
They are among the biggest explosions of radio energy in the entire universe.
The night sky is poised for a dramatic change as Antares, a red supergiant 700 times larger than our sun, nears the end of its life. On the verge of a supernova, its explosion could outshine even Betelgeuse and rival the brightness of our entire galaxy. As we await this cosmic event, one question remains. What will happen when this stellar giant finally erupts? Observable supernovae within our galaxy are exceedingly rare. The last recorded instance occurred centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This impending celestial display offers astronomers and space enthusiasts a unique opportunity to witness cosmic history unfold before their eyes. As we embark on this journey through the cosmos, we'll explore the far-reaching impacts of this stellar explosion. From the creation of heavy elements to the potential formation of neutron stars or black holes, the aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant. Antares, a red supergiant located approximately 604 light-years from Earth, is a cosmic behemoth that captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many observers of the night sky. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, are a testament to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the Scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching several % of the speed of light. To put this into perspective, imagine a mass several times that of our sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shock waves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for heavy elements. The intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects, where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, no supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernovae in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Corona Borealis. This system consists of a red giant star and a white dwarf, locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Corona Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Corona Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Corona Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Corona Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal. These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust, forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernovae and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins and place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet, despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this. The last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our earthly vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, it would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of Antares supernova would be a game-changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernova across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe.
In the quest to find another Earth, scientists have turned their gaze to Proxima b, our closest exoplanet neighbor. But the James Webb Space Telescope's latest image reveals a world that's both tantalizingly similar and alarmingly different from our own.
We have found a planet around the nearest star, Proxima Centauri. So this discovery didn't happen, obviously, from one day to the next.
So what's the closest Earth-like planet you think is worth visiting? How hard is it?
Proxima Centauri. It's over 4 light years away, and we can't travel at the speed of light. Today, there are plans that have planted the seed that shift this line, how we could send probes there.
The James Webb Space Telescope, humanity's most advanced eye in the sky, has recently captured the clearest image of Proxima b to date. This groundbreaking achievement marks a significant milestone in our understanding of exoplanets and the potential for extraterrestrial life. The unprecedented clarity of this image allows scientists to study Proxima b's features in detail, offering new insights into its composition and environment. As we delve deeper into the mysteries of Proxima b, we find ourselves at the intersection of hope and adversity. The planet's proximity to Earth makes it an enticing target for exploration, yet its harsh conditions pose formidable challenges. In the following sections, we'll explore the complex nature of Proxima b and the technological marvels that have made this discovery possible, unraveling the enigma of our cosmic neighbor. Our closest exoplanet neighbor, Proxima b, our closest exoplanet neighbor, orbits the star Proxima Centauri at a distance of just 4.2 light-years from Earth. This proximity makes it a prime target for scientific study and exploration. Despite its relative closeness, Proxima b remains shrouded in mystery, presenting a complex puzzle that challenges our understanding of planetary formation and habitability. Recent measurements have revealed intriguing details about Proxima b's physical characteristics. The planet has a minimum mass that is 17% greater than Earth's, suggesting it may be more Earth-like than previously estimated. This increased mass could indicate a rocky terrestrial composition similar to our own planet. Adding to its allure, Proxima b completes an orbit around its star every 11.2 Earth days, a remarkably short period that speaks to its close proximity to Proxima Centauri. One of the most exciting aspects of Proxima b is its location within the habitable zone of its star. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist on a planet's surface. This concept is crucial in the search for potentially habitable worlds, as liquid water is considered essential for life as we know it. The significance of Proxima b's position within the habitable zone cannot be overstated. It raises the tantalizing possibility that this distant world could harbor liquid water and, by extension, potentially support some form of life. This prospect has ignited the imagination of scientists and the public alike, fueling dreams of discovering life beyond our solar system. Recent advancements in technology have allowed for more precise measurements of Proxima b's characteristics. The espresso spectrograph, a powerful instrument designed to detect and study exoplanets, has provided new insights into Proxima b's nature. These latest measurements suggest that Proxima b could indeed be a rocky, terrestrial planet similar to Earth, further enhancing its potential for habitability. However, the story of Proxima b is not without its challenges. The planet's close proximity to its star, while allowing it to reside within the habitable zone, also presents significant obstacles. Proxima Centauri, a red dwarf star, is smaller and cooler than our Sun, but it poses unique threats to its planetary companion. The intense radiation emitted by Proxima Centauri raises serious concerns about Proxima b's ability to retain an atmosphere. Without a protective atmospheric layer, the planet's surface would be exposed to harmful stellar radiation, potentially making it inhospitable for life as we understand it. This close dance between planet and star creates a precarious balance, where the very factors that place Proxima b in the habitable zone also threaten its potential to support life. This tension between hope and adversity exemplifies the complex nature of exoplanet research. On one hand, Proxima b's Earth-like mass and position within the habitable zone fuel optimism about its potential to harbor life. On the other hand, the harsh realities of its stellar environment present significant challenges to its habitability. The harsh realities of Proxima b's environment. At the heart of Proxima b's story lies its host star, Proxima Centauri. This celestial body is a red dwarf, a class of stars that differs significantly from our Sun. Red dwarfs are smaller, cooler, and far more numerous than stars like our own. While their cooler temperatures might seem advantageous for nearby planets, the reality is far more complex. Proxima Centauri's diminutive size and lower temperature mean that its habitable zone, the region where liquid water could potentially exist on a planet's surface, is much closer to the star than in our solar system. This proximity creates a host of challenges for Proxima b, our nearest exoplanet neighbor. One of the most significant consequences of Proxima b's close orbit is the likelihood of tidal locking. This phenomenon occurs when a planet's rotation becomes synchronized with its orbit, causing one side to always face its star while the other remains in perpetual darkness. The implications of this are profound. Imagine a world where one hemisphere basks in eternal daylight while the other never sees its sun. This tidal locking leads to extreme temperature variations across Proxima B's surface. The side facing Proxima Centauri likely experiences scorching heat, potentially hot enough to melt rock. In contrast, the dark side might be locked in a permanent frigid night. Between these two extremes, there could be a narrow band, often called the terminator line, where temperatures might be more moderate. This twilight zone represents one of the few areas where conditions could potentially support life as we know it. However, temperature extremes are just the beginning of Proxima B's environmental challenges. The planet's close proximity to its star exposes it to intense radiation. Red dwarf stars, despite their smaller size, can be incredibly active and prone to powerful flares. These stellar outbursts pose a significant threat to any potential life on nearby planets. In April 2021, astronomers observed a flare from Proxima Centauri that was truly staggering in its intensity. This event was 100 times more intense than any flare recorded from our Sun, demonstrating the volatile nature of Proxima B's cosmic neighborhood. Such powerful flares could strip away a planet's atmosphere over time, leaving its surface exposed to harmful radiation. The radiation environment around Proxima B is further complicated by the star's magnetic activity. Researchers believe that the chaotic surface activity of Proxima Centauri leads to powerful magnetic fields that contribute to the high-energy radiation environment around Proxima B. This constant bombardment of radiation poses a significant challenge to the development and survival of life as we understand it. To put the intensity of this radiation into perspective, consider this. Proxima B experiences solar wind radiation that is approximately 1,000 times greater than what Earth receives. This relentless onslaught of charged particles and high-energy radiation would be devastating to most forms of life familiar to us. Given these harsh conditions, it's natural to question the possibility of life on Proxima B. As one researcher noted, while the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality seems far from hospitable. The combination of extreme temperatures, tidal locking, and intense radiation creates an environment that appears hostile to life as we know it. Another scientist remarked, "It's hard to imagine life surviving such intense radiation without specialized shelter." This statement encapsulates the challenge facing any potential life on Proxima B. To survive in such an environment, organisms would need to develop extraordinary adaptations or find ways to shelter from the constant barrage of radiation. Yet, it's crucial to remember that our understanding of life and its potential forms is limited to what we've observed on Earth. The very challenges that make Proxima B seem inhospitable also push us to expand our concepts of habitability and life itself. Could there be forms of life that thrive in conditions we consider extreme? Might the unique environment of Proxima B foster types of life entirely different from what we're familiar with? Technological marvels, overcoming the odds. In the face of Proxima B's extreme environment, humanity has risen to the challenge with remarkable technological innovations. At the forefront of this endeavor stands the James Webb Space Telescope, JWST, a marvel of engineering that has revolutionized our ability to study distant exoplanets. The JWST represents a quantum leap in space observation technology. Its advanced infrared imaging capabilities allow astronomers to peer through cosmic dust and gas, revealing details of exoplanets that were previously hidden from view. This breakthrough has been particularly crucial in our study of Proxima b, providing unprecedented clarity in imaging our closest exoplanet neighbor. What makes the JWST so exceptional in its ability to study Proxima b? The answer lies in its sophisticated suite of instruments and its strategic position in space. Orbiting the Sun about 1 million miles from Earth, the JWST is shielded from the interference of our planet's atmosphere and the heat of the Sun. This optimal positioning, combined with its large mirror and sensitive detectors, allows it to capture the faintest signals from distant worlds. The JWST's capabilities extend beyond mere imaging. Its instruments can analyze the light passing through an exoplanet's atmosphere, providing crucial data about its composition. This technique, known as spectroscopy, has the potential to detect biosignatures, chemical markers that could indicate the presence of life. While the JWST has captured the headlines, it's not the only technological marvel contributing to our understanding of Proxima b. The espresso spectrograph, installed on the Very Large Telescope in Chile, has played a pivotal role in refining our knowledge of this enigmatic world. Espresso's capabilities allow it to split light from Proxima b into its component wavelengths, enabling detailed analysis of the planet's characteristics. The precision of Espresso's measurements is truly astounding. Francesco Pepe, a co-author of the Espresso study, expressed satisfaction with the instrument's performance, stating, "We're really pleased that Espresso can produce even better measurements." This improved accuracy has allowed scientists to refine their estimates of Proxima b's mass and orbit, bringing us closer to understanding its true nature. Looking to the future, an even more ambitious project is on the horizon, the Starshot Initiative. This groundbreaking concept aims to send a fleet of tiny spacecraft to Alpha Centauri, potentially allowing us to study Proxima b up close. The Starshot project faces significant challenges, including the need for 100 gigawatts of power from 100 million lasers to propel a probe at 20% the speed of light. Despite these hurdles, the potential rewards are immense. If successful, Starshot could revolutionize our approach to space exploration, reducing travel time to Proxima b from thousands of years to mere decades. The technological challenges of the Starshot initiative are formidable. The spacecraft designed for this mission must reflect 99.99% of incoming light to prevent overheating during its journey. Additionally, the Starshot team is exploring the use of adaptive optics to overcome atmospheric interference, allowing for a more focused laser beam on the spacecraft. These innovations push the boundaries of what's currently possible in space technology. Each of these technological marvels, the JWST, Espresso, and the proposed Starshot initiative, represents a testament to human ingenuity and our relentless pursuit of knowledge. They allow us to overcome the vast distances and harsh conditions that separate us from Proxima b, bringing us closer to understanding our cosmic neighborhood. The search for life, hope amidst adversity. Proxima b stands as a testament to the complexity of our cosmic neighborhood. Its status as our closest exoplanet neighbor, coupled with its location within the habitable zone of Proxima Centauri, makes it a prime candidate for potential life. However, the harsh realities of its environment present significant challenges to this possibility. The planet's Earth-like mass and position within the habitable zone initially fueled optimism about its potential to harbor life. These factors suggest that Proxima b could have a rocky composition and might support liquid water on its surface. Two crucial elements in our search for habitable worlds. Yet, the very proximity to its star that places Proxima b in the habitable zone also exposes it to extreme conditions that could render it inhospitable. The intense radiation from Proxima Centauri, particularly the powerful flares observed in recent years, poses a significant threat to any potential life on the planet. This constant bombardment of high-energy particles could strip away Proxima b's atmosphere over time, leaving its surface exposed to harmful radiation. The likely tidal locking of the planet further complicates matters, creating extreme temperature variations across its surface. In the midst of these challenges, a recent discovery has reignited interest in the search for life beyond our solar system. Astronomers detected a mysterious signal from the Alpha Centauri system at a frequency of 982.07 MHz. This finding has sparked speculation about the possibility of intelligent life in our cosmic backyard. While some experts suggest that the signal might originate from manufactured equipment, others remain cautiously optimistic that it could indicate extraterrestrial intelligence. The discovery of this signal serves as a stark reminder of the potential for groundbreaking discoveries in our quest to understand the universe. It underscores the importance of continued exploration and study of nearby star systems, including Proxima Centauri and its intriguing exoplanet, Proxima b. Studying Proxima b offers a unique opportunity to refine our understanding of what makes a planet truly habitable. By examining how extreme conditions affect the potential for life, scientists can expand their criteria for habitability beyond Earth-like standards. This approach could lead to new insights into the resilience and adaptability of life in diverse environments. The harsh conditions on Proxima b challenge us to reconsider our definitions of life and habitability. Could there be forms of life that thrive in environments we consider extreme? Might the unique conditions on Proxima b foster types of life entirely different from what we're familiar with on Earth? These questions push the boundaries of our scientific understanding and imagination. As we gather more data about Proxima b, we are compelled to balance scientific possibility with the harsh realities of space environments. While the planet's proximity and location within the habitable zone offer hope, the intense radiation and extreme temperature variations present significant obstacles. This delicate balance between optimism and realism drives the continued exploration and study of our nearest exoplanet neighbor. The James Webb Space Telescope's recent capture of the clearest image of Proxima b to date marks a significant milestone in our understanding of this enigmatic world. This technological achievement allows scientists to study Proxima b's features in unprecedented detail, offering new insights into its composition and environment. Such advancements bring us closer to unraveling the mysteries of our cosmic neighbor and potentially answering the age-old question: are we alone in the universe? Future prospects. The road to Proxima b. The journey to Proxima b represents one of humanity's greatest challenges in space exploration. With current technology, reaching our nearest exoplanet neighbor would take approximately 6,000 years. This staggering time frame underscores the vast distances that separate us from even our closest cosmic neighbors. It's a stark reminder of the limitations we face in our quest to explore the universe beyond our solar system. However, human ingenuity continues to push the boundaries of what's possible. Enter the Starshot Initiative, an ambitious project that aims to drastically reduce the travel time to Alpha Centauri, the star system that hosts Proxima b. This groundbreaking endeavor targets a journey of just 22 years, a fraction of the time required by conventional spacecraft. The Starshot project proposes to achieve this feat through a revolutionary approach to space travel. It plans to utilize a fleet of small probes, each about 10 meters in diameter, propelled by powerful lasers. These spacecraft would travel at an astonishing 20% of the speed of light, enabling rapid exploration of Proxima b and its surroundings. The scale of this undertaking is truly mind-boggling. The Starshot initiative requires an immense power output of 100 gigawatts, equivalent to the entire electricity consumption of the United States. However, this enormous power would only need to be sustained for about 10 minutes to launch the probes on their interstellar journey. Once launched, these probes would embark on a 2-decade journey across the cosmic void. Upon reaching Alpha Centauri, they would have approximately 2 hours to gather data and transmit it back to Earth. This transmission would then take an additional 4 years to reach us, adding to the complexity of interstellar communication. The potential impacts of successfully exploring Proxima b extend far beyond the realm of scientific discovery. Such an achievement would mark a new chapter in human history, fundamentally altering our perspective on our place in the universe. It would provide unprecedented insights into the nature of exoplanets, potentially answering age-old questions about the prevalence of life beyond Earth. From a philosophical standpoint, the exploration of Proxima b challenges us to reconsider our role as a species. It pushes us to contemplate the possibilities and responsibilities that come with becoming an interstellar civilization. The knowledge gained from such a mission could reshape our understanding of planetary formation, evolution, and the conditions necessary for life to emerge and thrive. However, as we contemplate the exploration and potential colonization of other worlds, we must also grapple with significant ethical considerations. The idea of altering another planet's environment raises complex questions about our rights and responsibilities as cosmic explorers. Should we intervene in the natural processes of other worlds? What precautions should we take to prevent contamination or unintended consequences? These ethical dilemmas become even more pronounced if we were to discover any form of life on Proxima b, no matter how primitive. The potential impact on indigenous life forms, even microbial ones, must be carefully considered in any exploration or colonization efforts. A new chapter in space exploration. The exploration of Proxima b marks a new frontier in our quest to understand the universe. This enigmatic world, both tantalizing and treacherous, challenges our notions of habitability. Its Earth-like mass and position in the habitable zone offer hope, while its harsh radiation environment and extreme temperatures present significant obstacles. Technological marvels like the James Webb Space Telescope and espresso spectrograph have revolutionized our ability to study this distant world, providing unprecedented clarity and detail. The potential Starshot initiative represents humanity's ambition to bridge the vast distances of space. As we continue to unravel Proxima b's mysteries, we expand our understanding of what makes a planet truly habitable and push the boundaries of our technological capabilities. This journey of discovery reflects humanity's enduring drive to explore the unknown, even in the face of seemingly insurmountable challenges.
5, 4, 3, 2, 1, 0. All engine running.
I am Buzz Aldrin.
One small step for man, one giant leap for mankind.
And I was the lunar module pilot on Apollo 11.
Ready, 5 clear. Roger.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Buzz Aldrin, one of the few men to have walked on the moon, possesses unique insights about it thanks to his experience as a lunar astronaut. Later in life, he shared intriguing observations, hinting at mysterious entities or phenomena close enough to be observed on the moon. Does Aldrin's observations challenge conventional knowledge about the moon?
I thought it was a good idea in front of the TV to bounce around and to demonstrate how easy a guy could move around, or a gal could move around on the moon.
Is the moon not what we think it is? Let's learn more about this person. Buzz Aldrin, an astronaut renowned for his academic prowess, including a PhD from MIT, played an instrumental role in the historic Apollo 11 mission as the lunar module pilot. As the pilot of the lunar module, Aldrin had a massive job. He had to land on the moon and then make sure they could get back to Earth safely. This guy wasn't just very intelligent. He was also a top fighter pilot in the Korean War. His mix of brainpower and flying skills was key to the mission's success. But there's more. We're also looking at how Aldrin kept his cool under pressure. Imagine this: you're descending to the moon and you're hit with computer alarms, unknown boulders on the surface, and your fuel's running low. Sounds scary, right? Well, Aldrin, alongside Neil Armstrong, handled it like a pro. His ability to stay calm and make quick, smart decisions was crucial, especially during those tense moments. Thanks to him, the Eagle landed safely on the moon. Stay tuned as we explore the amazing journey of Buzz Aldrin on Apollo 11. The historic moon landing. Guess what? Buzz Aldrin was the second guy to walk on the moon, right after Neil Armstrong. When he stepped onto the moon, he didn't just make history, he became a part of it. But walking on the moon was just one part of his mission. Aldrin was super busy up there, setting up all sorts of science experiments. These weren't just any experiments. They were designed to help us learn everything about the moon, like what it's made of and what its surface is like. Thanks to him, we know a lot more about the moon now. Aldrin also did something really important. He planted the American flag there. This wasn't just about being patriotic. It was a big moment showing what humans can achieve when we aim for the stars. And there's the special thing he did that not many people know about. While he was on the moon, Aldrin took some time for a personal spiritual moment. He actually took communion. It's a reminder that behind all the science and exploration, there's a human touch. Let's talk about how Aldrin described the moon. He called it magnificent desolation. What a way to describe it. It's like he was saying the moon is incredibly beautiful, but also really empty and quiet. It must have been such an unreal experience to stand there in this huge, silent place, so far from Earth. Space sickness experience. Let's dive into something that is about Buzz Aldrin that is not talked about much. His experience with space sickness during the Apollo 11 mission. You know, being an astronaut is not just about the cool stuff like floating in zero gravity or walking on the moon. There are some tough challenges too, and space sickness is definitely one of them. You can compare it with seasickness if you have ever had it before. Now, when Aldrin was up there in space, he actually got really sick. But here's the thing. Back then, nobody really talked about it. It wasn't until later, in his autobiography and some interviews, that Aldrin opened up about this experience. This was a big deal because it showed a side of astronauts we don't often see, their human, vulnerable side. Space sickness, or what they call motion sickness in space, can be pretty rough. Imagine feeling dizzy, nauseous, and just all around terrible while you're trying to do your job millions of miles away from Earth. It's not fun. Aldrin dealing with this while on such an important mission just shows how tough and resilient astronauts have to be. But why is this important? Well, it reminds us that astronauts are people too. They face challenges and have to overcome them just like the rest of us. Aldrin sharing his story of space sickness helps us understand and appreciate the real human side of space exploration. It's not always smooth sailing or smooth flying in this case. Theories on extraterrestrial life and moon's far side. Now let's talk about something that's really out of this world. Buzz Aldrin has dropped some hints that have got everyone talking. He suggested that there might be hidden structures or even bases on the far side of the moon. This could mean something huge, like ancient civilizations or extraterrestrial activity. This idea isn't just some sci-fi fantasy. It's coming from a man who's actually walked on the moon. So when Aldrin talks about these possibilities, people listen. His comments have sparked a ton of interest and loads of speculation, not just among space enthusiasts, but even in the scientific community. Now think about it. The far side of the moon is this mysterious place that we've never seen from Earth. So when someone like Aldrin hints at something hidden over there, it's no wonder everyone's imagination goes into hyperdrive. Could there be structures we've never seen before? Signs of ancient moon visitors? Maybe even evidence of aliens? These ideas have sent people rushing to look at lunar images and data, searching for any clues that might support Aldrin's suggestions. But here's the thing. While some people claim they found evidence of weird structures or unnatural formations on the moon, a lot of it could be our brains playing tricks on us, seeing patterns that aren't really there. That said, the fact that a seasoned astronaut like Aldrin even entertains these ideas adds a serious dose of intrigue to the whole discussion. Observation of a mysterious object in space. During the historic Apollo 11 mission, Aldrin reported something extraordinary. He observed an object in space that he couldn't identify. This wasn't just a piece of their spacecraft or some random space junk. It was something different, something that even a seasoned astronaut like Aldrin couldn't recognize. Now, imagine this. You're thousands of miles away from Earth in the vast emptiness of space, and you see something mysterious floating out there. That's exactly what happened to Aldrin. This wasn't a quick glimpse either. He saw an object that seemed to move in a controlled way, not just tumbling through space like debris. This sighting was unusual enough to catch the attention of the entire crew. This sighting sparked a lot of conversations and theories, especially about the possibility of extraterrestrial life. It's one of those incidents that make you wonder what's really out there. Was it an optical illusion, a reflection, or something more? Some space enthusiasts even dared to ask if it could be evidence of intelligent life, taking an interest in humanity's first journey to the moon. Aldrin has been open about this experience, discussing it in interviews and being transparent about what he saw and felt. He didn't jump to any wild conclusions, but he also didn't dismiss what he saw as nothing. This account from Apollo 11 adds a layer of mystery and excitement to the mission's story. Belief in extraterrestrial life. Aldrin has some other fascinating thoughts about life beyond Earth. Think about it. The universe is incredibly huge, with billions of galaxies, each filled with billions of stars. Around those stars orbit countless planets. Aldrin thinks that in all that immense space, it's almost more unlikely that Earth is the only place with life. He's not just dreaming big. He's basing his ideas on the probabilities given the size of the cosmos. But Aldrin doesn't stop at just believing there's life out there. He's a big advocate for continuing to explore space, to push further into the unknown. Why? Because he thinks that by exploring, we might actually find other life forms. Imagine the breakthroughs and the leaps in understanding we could achieve if we encountered life beyond Earth. Aldrin's perspective is really a call to action for humanity. He's urging us to keep exploring space, not just to satisfy our curiosity, but also to connect with potential life out there. This isn't just about launching rockets and satellites. It's about a deeper understanding of our place in the universe. Life on the moon, possibilities and challenges. Now, when we think of the moon, we usually picture this barren, desolate landscape with extreme conditions. It's a place with no atmosphere, extreme temperature swings, and bombarded by cosmic rays and solar winds. Not exactly the kind of spot you'd think life would call home, right? But there's more to this story. It's this wild idea that life can actually hitch a ride across the cosmos, potentially even reaching the moon. This could happen through asteroids, comets, or even interstellar dust. Imagine tiny life forms or organic materials getting a lift from Earth or other planets and ending up on the moon. But that's not the only way life could make it to the moon. Human activity could also play a part. We've been sending spacecraft and landers to the moon since the 1950s. Now, what if some of these missions accidentally carried microscopic stowaways? It's entirely possible. In 2019, an Israeli spacecraft called Bereshit crashed on the moon. But it wasn't alone. It had a payload that included thousands of tardigrades. If you don't know what tardigrades are, they're these tiny, tough animals that can survive extreme conditions. We're talking about surviving in space. So there's a chance these little guys could be living it up on the moon right now. Now, we're not saying there's a thriving ecosystem up there. If there's any life on the moon, it's probably super simple, like bacteria or fungi. And it would have to be in very isolated spots, like inside rocks or in ice at the poles. While it's unlikely that the moon has its own native life forms, the idea that life could hitch a ride that isn't so far-fetched. It's these kinds of possibilities that make space exploration so exciting. We're constantly learning and reevaluating our understanding of life in the cosmos. What do you think? Do you believe in Buzz Aldrin's observations? Could it possibly be any life beyond our planet, or even on our neighbor the Moon? Let us know your thoughts in the comments below. We hope you found these facts intriguing. If you heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.
Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating.
It's very unstable. It's about to explode.
No, give me the timescale for that.
The thing is, it could be tomorrow.
The entire universe will be aware of this one explosion.
Betelgeuse, the colossal red supergiant blazing at the shoulder of Orion, just experienced a staggering 150% surge in brightness, an enigmatic pulse that has astronomers buzzing with excitement. This cosmic titan has a history of erratic behavior, with recent outbursts suggesting it could be on the brink of a supernova explosion. But when will it happen? What does this mean for our understanding of the universe? As we delve into the mysteries surrounding this giant, we'll uncover how Betelgeuse's unprecedented brightness changes are rewriting what we know about stars and bringing us closer to an astronomical spectacle that could light up our sky for weeks. The recent brightening surge. In a recent and stunning astronomical event, the James Webb Space Telescope has captured a significant increase in the brightness of Betelgeuse, one of the most well-known stars in our night sky. This red supergiant, typically noted for its steady glow on the shoulder of the Orion constellation, has recently surged to become the 7th brightest star visible from Earth. The brightness of Betelgeuse has peaked at an astonishing 150% above its usual luminosity. This sudden and unexpected brightening of Betelgeuse offers a unique spectacle for both amateur stargazers and professional astronomers. Positioned in a constellation familiar to many, its enhanced brilliance makes it an even more striking feature in the night sky. The increased brightness is not just a trivial change. It represents significant and dynamic processes occurring in the star's life cycle. Such a surge in luminosity could be linked to changes in the star's surface temperature, size, or radiative processes, showcasing the unpredictable nature of these celestial giants. As the star currently ranks as the 7th brightest, its prominence in the sky is a call to observers and scientists to watch closely. Each observation and data point collected helps in piecing together the complex life story of stars like Betelgeuse. The James Webb Space Telescope, with its advanced capabilities, continues to monitor these changes, providing crucial insights into the behavior of stars on the brink of their evolutionary shifts. This event not only enriches our understanding of stellar dynamics, but also enhances the nightly spectacle for skywatchers around the globe. Supernova anticipation. As the enigmatic red supergiant Betelgeuse continues to dazzle stargazers and astronomers alike, anticipation is mounting over the possibility of it going supernova, a stellar explosion that could offer a spectacle unlike any other seen in our lifetimes. Betelgeuse, a behemoth star nearing the end of its life, has sparked a wave of speculation due to its unusual and dramatic fluctuations in brightness. This has led many to wonder, are we on the brink of witnessing a supernova? Experts in the field are closely monitoring Betelgeuse, predicting that it might explode into a supernova within the next few decades. This potential timeline, however, contrasts starkly with NASA's more conservative estimate, which suggests that Betelgeuse's supernova event may not occur for another 100,000 years. This disparity in predictions underscores the complexities and uncertainties inherent in studying such colossal celestial phenomena. The prospect of Betelgeuse's supernova has not only captivated the scientific community, but has also permeated popular discussions. The idea that we could soon witness one of the most significant events in our galaxy, an event so bright that it could outshine the moon and be visible during daylight hours, stirs a blend of excitement and awe. This anticipation is further fueled by our limited understanding of supernovae, as each observation provides critical data that can redefine what we know about the life cycle of stars. Thus, the watchful eyes of the world remain fixed on Betelgeuse, eagerly awaiting any signs that may hint at its imminent transformation. Whether this spectacular event occurs in the near future or millennia from now, the ongoing study of Betelgeuse offers invaluable insights into the final days of a star's life. Historical brightness patterns. Betelgeuse's erratic luminary ballet has fascinated skywatchers across the millennia. From the indigenous Australians to the ancient Greeks, the star's periodic brightening and fading have been meticulously observed and documented, embedding Betelgeuse deeply into cultural lore and astronomical study alike. Traditionally, this red supergiant exhibited a predictable brightness cycle lasting approximately 400 days. However, recent observations have painted a different picture, revealing a shift to a much shorter 130-day cycle. This significant change in Betelgeuse's behavior marks an atypical deviation from its historic patterns. What could possibly cause such a dramatic alteration in its cycle? This question captivates astronomers and adds a layer of mystery to an already enigmatic celestial body. The shift suggests an underlying change in the star's internal processes or external influences that we are yet to fully understand. The implications of these rapid cycles are profound, both for our theoretical understanding of stellar physics and for the practical monitoring of Betelgeuse. As we continue to observe this star, each cycle of brightening and dimming could bring us closer to unraveling the secrets of its celestial mechanics and perhaps predicting its ultimate fate. For now, the rapid changes serve as a celestial puzzle, connecting the curiosity of ancient civilizations with the high-tech investigations of modern astronomy. The Great Dimming Event. In late 2019, the astronomy community was abuzz as Betelgeuse, one of the most well-known stars in the night sky, began to exhibit some highly unusual behavior. This red supergiant star, famous for its brilliant reddish hue and prominent position in the Orion constellation, unexpectedly dimmed by an astonishing 60%. This phenomenon, quickly dubbed the Great Dimming, sparked a wave of speculation among scientists and stargazers alike, many of whom wondered if Betelgeuse was about to go supernova. The dimming was so significant that it was clearly visible even to casual observers, marking a stark change from the star's typically bright appearance. The sudden shift led to numerous theories about the star's imminent death and transformation into a supernova, which would have been a spectacle visible across vast distances in the galaxy. However, as astronomers monitored the star more closely using the world's most advanced telescopes, a different explanation emerged. It was discovered that the Great Dimming was not a sign of impending supernova, but rather the result of a colossal surface eruption on Betelgeuse. This massive explosion had expelled a significant cloud of dust away from the star's surface. The cloud was large enough to obscure the light coming from Betelgeuse, leading to its dramatically reduced luminosity as observed from Earth. This finding was crucial as it not only provided a rational explanation for the dimming, but also offered a rare insight into the kinds of surface activities that can occur on red supergiants like Betelgeuse. The Great Dimming served as a reminder of the dynamic and ever-changing nature of stars, regardless of their age or size. It highlighted the complex interplay of forces operating in these colossal celestial bodies, and how they can lead to spectacular, if misunderstood, events that can momentarily trick us into believing that a star's end is near. Moreover, this episode allowed astronomers to study the mechanisms behind such massive ejections and how they affect the star's behavior and evolution. Understanding these processes is vital for predicting the life cycles of similar stars and preparing for the actual supernova events that one day will light up our skies. Star size and structure. Imagine, if you will, placing Betelgeuse at the center of our solar system. This colossal red supergiant would not merely loom large in our sky. It would engulf it, extending beyond Mars and reaching all the way past Jupiter. This staggering size isn't just for show, it fundamentally affects how Betelgeuse behaves as a star. Betelgeuse is classified as a red supergiant, a type of star that has exhausted the hydrogen in its core and expanded massively as a result. The sheer scale of Betelgeuse can be hard to comprehend. In comparison, if our Sun, a mere speck in size against the backdrop of Betelgeuse, were to suddenly expand to the red supergiant's proportions, it would swallow Mercury, Venus, Earth, and Mars, creating a catastrophic end for our planet. But why does this immensity lead to increased variability? The answer lies in the star's unstable nature. The outer layers of Betelgeuse are only loosely bound to its core due to its vast radius and the relatively low gravitational pull at its surface compared to smaller, more compact stars. This causes the star to pulsate irregularly, significantly changing its brightness as seen from Earth. Additionally, this pulsation allows large convective cells to form and move hot gas from deep inside the star to the surface. When this hot gas reaches the outer layers, it cools and sinks back toward the core, a stellar conveyor belt of sorts that not only stirs the star's atmosphere, but also contributes to the star's periodic dimming and brightening. Understanding Betelgeuse's structure gives astronomers critical clues about the life cycles of red supergiants and how such stars end their lives. Given Betelgeuse's advanced age and bloated size, it stands as a perfect laboratory for studying the final stages before a star goes supernova, offering insights not just into the star itself, but into the broader mechanisms governing stellar evolution, scientific observations and tools. In our quest to unravel the mysteries of the cosmos, the role of advanced astronomical observatories cannot be overstated. Tools like the James Webb Space Telescope, the Hubble Space Telescope, and the Very Large Telescope stand as pillars of modern astronomy, providing us with the essential data needed to decode the behavior and structural changes of stars like Betelgeuse. The James Webb Space Telescope, with its unparalleled infrared sensitivity, allows astronomers to peer into the dusty veils surrounding stars, revealing hidden structures and temperatures that were once beyond our reach. This ability is crucial when studying a star like Betelgeuse, which often shrouds itself in a cloud of its own making. Meanwhile, the Hubble Space Telescope continues to offer invaluable support with its high-resolution capabilities. Its observations have helped track changes in Betelgeuse's size and surface activity over the years, providing a clearer picture of its pulsations and occasional ejections of material. The Very Large Telescope, situated in the arid deserts of Chile, complements these observations with its own unique capabilities. It employs a suite of instruments that can capture high-resolution images and spectra, allowing scientists to observe the star in different light spectrums. This multifaceted approach is essential, as the different wavelengths can tell us about various aspects of the star's surface and atmospheric conditions. The synergy of these observatories has turned Betelgeuse into one of the best-studied stars in our night sky. Each telescope contributes a piece to the puzzle, from mapping the star's vast surface to monitoring its light fluctuations and spectral signatures. This collaborative global effort not only enhances our understanding of Betelgeuse, but also sets the stage for understanding other similar stars across the galaxy. Through the lenses of these powerful observatories, we continue to witness the life story of one of the most intriguing stars visible to the naked eye. Astrophysicist Insights. As we delve deeper into the mysterious life cycle of Betelgeuse, it's crucial to consider the insights from renowned astrophysicist Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics. Dupree's research into this massive red supergiant reveals that Betelgeuse might currently be in a pivotal phase of its stellar evolution. According to her observations, the star could be nearing the end of its core carbon burning stage, a critical phase just before a star transitions into a supernova. The core carbon burning stage is one where a star like Betelgeuse converts its core carbon into heavier elements such as oxygen and magnesium. This process is a precursor to the collapse of the star's core, which could trigger the explosive and spectacular demise known as a supernova. Dupree suggests that this phase could conclude within the next few decades, positioning Betelgeuse on the brink of an epic cosmic event. What's particularly fascinating is how this assessment aligns with the unusual behavior we've observed from Betelgeuse in recent years. The increased frequency and intensity of its brightness fluctuations could be signaling that these internal transformative processes are more advanced than previously understood. This insight not only helps astronomers predict the star's future, but also offers a rare observational opportunity to study the pre-supernova activities in real time, a chance to witness firsthand the final chapters in the life of a star destined to end in a blaze of glory. Historical expectations. In the cosmic arena, our understanding of supernovae has been dramatically reshaped over recent decades. It was once firmly believed that only red supergiants were capable of culminating their stellar life cycles in the dramatic explosions known as supernovae. This view held sway in the astronomical community, grounding our predictions and theories in a framework that seemed unshakable, until 1987, that is. The year 1987 marked a pivotal shift in cosmic perceptions with the surprise supernova of a blue giant. This event sent shockwaves through the scientific community, challenging the long-held belief restricted to red supergiants. The blue giant, significantly hotter and more massive than its red counterparts, defied the expectations by undergoing a supernova, thereby expanding the scope of our understanding of stellar death. This paradigm shift not only widened our horizons regarding which stars could potentially go supernova, but also deepened our curiosity about the life cycles of stars across the spectrum. It underscored a fundamental lesson in astronomy. The universe often holds surprises that defy our expectations and assumptions. Each such event not only adds a new layer to our understanding, but also humbles us, reminding us of the vastness and the mystery of the cosmos that surrounds us. As we continue to observe and study stars like Betelgeuse, we do so with an awareness that what we know is only a fraction of what there is to learn, and what we expect is not always what occurs. Neutrino signals. In the cosmic ballet of the universe, neutrinos, those tiny, nearly massless particles, play a crucial yet often overlooked role. As Betelgeuse inches closer to its dramatic finale as a supernova, it's not just the visible light that will herald its cataclysmic end. Enter the neutrinos, ghost-like particles that rarely interact with matter. These particles could be the earliest messengers of Betelgeuse's impending supernova, providing a crucial heads-up before any visual confirmation is possible. Neutrinos are released in vast quantities during the core collapse of a supernova, a moment when the star's core implodes under its own gravitational pull, moments before the outer layers explode. The fascinating aspect of these particles is their ability to escape from the dense core of the star almost immediately after the collapse begins, traveling through space at nearly the speed of light. This means that neutrinos can reach Earth hours, perhaps even days, before the light from the supernova itself, which can get delayed as it bounces around within the exploding star. For astronomers and astrophysicists, detecting these neutrinos would not only signal that Betelgeuse has finally gone supernova, but also provide invaluable data about the processes occurring within the star's core in its last moments. Around the globe, detectors like the Super Kamiokande in Japan or the Ice Cube Observatory at the South Pole stand ready to catch these elusive particles. The detection of neutrinos from Betelgeuse would be a monumental event, marking only the second time in history that neutrinos from a supernova have been detected, the first being from supernova 1987A, which provided key insights into the life cycle of massive stars. As we monitor Betelgeuse's erratic behavior and shifting luminosity, the watch for neutrinos continues in earnest. These particles may soon serve as the silent heralds of one of the most significant astronomical events of our time, providing a precious few hours warning that a supernova spectacle is about to illuminate the heavens. This early warning could catalyze a flurry of scientific activity, with telescopes across the Earth poised to capture every moment of this stellar explosion in unprecedented detail. Thus, while Betelgeuse's light will fade, its legacy will shine brightly in the annals of astronomical discovery, enhanced by the ghostly glow of neutrinos. Potential impact of supernova. Imagine a day when you look up at the sky and see something brighter than Venus, bright enough to cast shadows on the ground at night. This isn't a scene from a science fiction movie. It's a very real possibility that could occur when Betelgeuse, one of the night sky's most notable stars, goes supernova. Betelgeuse, a massive red supergiant, is nearing the end of its life, and its eventual explosion as a supernova will be a sight to behold. The sheer magnitude of this event is hard to fathom. For context, Venus, often the brightest object in the night sky after the moon, can sometimes be visible during the day. Betelgeuse's supernova, however, will outshine Venus dramatically. This incredible luminosity means that for a period, possibly weeks, Betelgeuse will be visible both during the day and night, turning from a faint star seen in a dark night sky to a celestial beacon visible even under the sun's glare. What's even more fascinating is that despite its formidable appearance and intensity, this supernova poses no direct threat to Earth. The distance of Betelgeuse from our planet ensures that while the spectacle will be stunningly bright, it will not affect our environment or health. Instead, it offers a unique, harmless viewing opportunity that combines the thrill of a once-in-a-lifetime astronomical event with the safety of an ordinary celestial observation. For those worried about potential dangers, it's reassuring to know that while supernovae can emit harmful gamma rays and other energetic emissions, Betelgeuse's distance of about 650 light-years is enough to dilute these effects to negligible levels. The most impactful part of this event for us on Earth will be its breathtaking visibility and the way it lights up the sky, a phenomenon that will allow everyone around the globe to witness astronomical history in the making. In sum, Betelgeuse's dramatic changes offer an unprecedented glimpse into the late stages of red supergiants, refining our knowledge of stellar evolution and supernova mechanisms. By studying its unpredictable behavior, we uncover new insights into the universe's grand cycles, ultimately enriching our understanding of cosmic phenomena. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
We thought they were iced over and barren. We thought they were totally lifeless, no liquid water. Then the shock was, we find that underneath the ice, there's an ocean.
It's cool when you look up and you know that around every fifth one, there's a planet that's at the right distance, so not too hot and not too cold, and a rock so small enough. And so it could potentially be a habitat, as you said.
There is a planet with water and continents that it also has the ingredients for life.
The universe is teeming with planets outside our solar system, and each one offers a unique glimpse into the vast complexities of space. Enter the James Webb Space Telescope, JWST, a marvel of modern science and a beacon of hope for astronomers searching for Earth-like planets. The JWST, with its unparalleled ability to peer into the depths of space through infrared eyes, has transformed our quest to understand distant worlds. Today, we're diving deep into one of JWST's most thrilling revelations yet, the discovery of Gliese 163c. This exoplanet, located in the habitable zone of its star, presents conditions that might just support life as we know it. Gliese 163c is not just another celestial body. It represents a potential future, a new chapter in human exploration, and perhaps the answer to the age-old question, are we alone in the universe? The telescope, the James Webb Space Telescope, JWST, stands as a pinnacle of astronomical technology equipped with tools specifically designed to observe distant exoplanets with unprecedented clarity and depth. Among its suite of sophisticated instruments, the near-infrared camera, NIRCam, is pivotal. NIRCam not only captures detailed images of exoplanets, but also analyses their atmosphere by observing the light passing through it when a planet transits its star. This helps identify elements that might indicate habitable conditions or even the presence of life. Another groundbreaking instrument aboard the JWST is the Mid-Infrared Instrument, MIRI. MIRI extends the telescope's vision further into the infrared spectrum, which is crucial for studying cooler celestial objects. This capability is vital for examining the thermal characteristics of an exoplanet, providing insights into its surface temperature and conditions that are essential for assessing habitability. Equally important, the near-infrared spectrograph, NIR-SPEC, allows astronomers to dissect the chemical makeup of an exoplanet's atmosphere by spreading out the starlight into a spectrum. This tool can detect water vapor, methane, and other organic compounds, offering clues about the potential for life as we understand it. With these advanced tools, the James Webb Space Telescope not only seeks to find exoplanets, but also to explore them in a depth that was previously unimaginable, bringing us closer than ever to understanding whether planets like Gliese 163c could truly be called Earth's cousins. The discovery. The James Webb Space Telescope made headlines with its discovery of Gliese 163c, an exoplanet that quickly captured the attention of astronomers and space enthusiasts alike. This significant find was announced after JWST's detailed analysis of the star system Gliese 163, located about 49 light-years away in the constellation Dorado. Using its advanced near-infrared spectrograph, JWST was able to detect the chemical signatures and thermal properties that suggest Gliese 163c might be within the star's habitable zone. Initial observations of Gliese 163c indicated several exciting possibilities. The planet's orbit places it at just the right distance from its star to potentially allow liquid water to exist on its surface, an essential criterion for Earth-like life. Moreover, the spectral data revealed hints of an atmosphere, which is another critical factor in considering the habitability of a planet. These early findings have laid the groundwork for more detailed studies, making Gliese 163c a prime candidate in the search for life beyond Earth. Criteria for habitability. When scientists search for potentially habitable planets like Gliese 163cc, they primarily focus on three critical criteria: atmosphere, temperature, and the presence of water. Each of these elements plays a pivotal role in supporting life as we understand it. Firstly, an atmosphere is crucial because it can regulate temperature, protect biological entities from cosmic and solar radiation, and provide essential gases that biological processes might require. For instance, an atmosphere rich in oxygen and nitrogen, like Earth's, can support aerobic life forms and water cycles. Secondly, the temperature of a planet is equally significant. It must be neither too hot nor too cold, enabling the existence of liquid water on the planet's surface. This Goldilocks zone is where temperatures are just right for liquid water to exist, not so cold that it freezes solid, and not so hot that it vaporizes away. Finally, the presence of water is often considered a key marker for life. Water is a solvent in which biochemical reactions occur, crucial for life on Earth. Thus, finding signs of water on Gliese 163c, whether in vapor form in the atmosphere or as liquid on the surface, would be a strong indicator that the planet could potentially be hospitable to life forms. These criteria guide astronomers as they use the JWST to observe exoplanets across the galaxy, searching for those rare worlds where conditions might just be right for life to emerge. Characteristics of Gliese 163c. Gliese 163c stands out in the cosmic lineup of exoplanets due to its intriguing characteristics. It orbits its host star, Gliese 163, at a distance that places it squarely within the star's habitable zone, which is the region where conditions might be just right for liquid water to exist on the planet's surface, a crucial factor for life as we understand it. The planet is approximately 6.9 times the mass of Earth, classifying it as a super-Earth. This size suggests a rocky composition with a more substantial atmosphere than our home planet, which could lead to a greenhouse effect, potentially warming the planet. The orbit of Gliese 163c is particularly fascinating. It completes a full revolution around its star in approximately 26 Earth days. Such a short orbital period indicates that the planet is much closer to its star than Earth is to the Sun. However, because Gliese 163 is a red dwarf and much cooler than our Sun, this proximity places Gliese 163c in the sweet spot for temperate conditions. Comparatively, Earth orbits the Sun every 365 days, which reflects our moderate distance from a much hotter star. The environmental conditions on Gliese 163c, inferred from its orbit and size, suggest a world that could host thick atmospheric layers capable of trapping heat. If water exists, its state, whether vapor, liquid, or ice, would heavily depend on atmospheric composition and surface pressure. In contrast, Earth's well-balanced atmosphere and magnetic field have created a stable environment where water can exist in all three states, supporting a diverse range of life forms. As we continue to study Gliese 163c, understanding these key differences and similarities will help scientists better assess the planet's potential for habitability and life. Technology behind the discovery. The James Webb Space Telescope leverages cutting-edge technology to unveil the secrets of distant worlds like Gliese 163c. Central to its success are several key instruments, each playing a vital role in this cosmic detective work. The near-infrared camera, NIRCam, is JWST's primary imager, capturing high-resolution images that bring distant stars and their orbiting planets into clearer view than ever before. This capability is crucial for spotting minute changes in brightness and position that hint at the presence of exoplanets. Additionally, the mid-infrared instrument, MIRI, provides new insights into the thermal characteristics of Gliese 163c, allowing scientists to analyze the heat signatures that differentiate it from its stellar background. MIRI's sensitivity to longer wavelengths is ideal for studying cooler objects in space, making it indispensable for assessing the habitability of colder, Earth-like planets. Another essential tool is the near-infrared spectrograph, NIRSpec, which can disperse the light from Gliese 163c into its component wavelengths. This spectroscopic analysis helps astronomers determine the planet's atmospheric composition by identifying specific molecular signatures, such as water vapor, methane, or carbon dioxide, key indicators of potential life-supporting environments. These instruments, working in concert, not only pinpoint the location and existence of planets like Gliese 163c, but also provide a detailed look at their atmospheres and possible conditions for life, ushering in a new era of exoplanet discovery. Data interpretation. Interpreting the data received from Gliese 163c is a meticulous process that begins with the initial reception of signals captured by the James Webb Space Telescope. These signals, primarily in the form of infrared light, are analyzed using a variety of computational models to determine the planet's atmospheric composition, surface temperature, and potential presence of water vapor, among other vital characteristics. The accuracy of these findings is paramount. To ensure reliability, astronomers employ several validation techniques. First, the data undergoes a peer review process, where multiple independent teams of scientists examine the findings. This collaboration helps to eliminate biases and verify the consistency of the results across different observational methods and software analyses. Additionally, the findings from Gliese 163c are cross-referenced with similar exoplanets data, providing a comparative baseline that bolsters the confidence in the interpretations. By integrating these methods, astronomers not only refine their understanding of Gliese 163c, but also enhance the broader scientific community's trust in these distant world observations. Hypothetical life forms. Gliese 163c, with its position firmly within the habitable zone of its star, ignites the imagination with possibilities of life. The conditions on this exoplanet, which closely mirror those of Earth in terms of temperature and potential water presence, lead us to consider what forms of life might thrive there. Picture, if you will, microbial life forms that have adapted to potentially extreme conditions, which could range from intense solar radiation to varying atmospheric compositions. Moreover, the possibility of more complex multicellular organisms cannot be dismissed. These organisms might possess unique adaptations to their environment, perhaps akin to extremophiles on Earth that thrive in the harshest conditions, from deep sea vents to the frozen tundras. The presence of liquid water, a critical ingredient for life as we know it, could mean that aquatic life forms might dominate the biosphere of Gliese 163c. Imagine creatures that have evolved not only to survive but to flourish in the alien oceans or lakes of this distant world, developing novel biochemistries that challenge our very conception of life. Each hypothesis not only expands our understanding of biology, but also deepens the awe and mystery surrounding our universe's potential to harbor diverse life forms. What this discovery means. The discovery of Gliese 163c as a potentially habitable planet has profound implications, both scientifically and philosophically. From a scientific standpoint, this finding challenges and expands our understanding of habitable environments. It prompts a re-evaluation of how we study planetary atmospheres and climates, pushing us to develop more sophisticated models to predict and comprehend life-supporting conditions. Moreover, Gliese 163c offers a real-time laboratory for testing theories about planetary formation, evolution, and the potential for sustaining life. Philosophically, the discovery stirs profound questions about our place in the universe. The existence of another potentially habitable planet inherently suggests the possibility of life beyond Earth, which could fundamentally alter our understanding of life's uniqueness and rarity. It encourages us to reflect on our responsibilities as a species and the ethical considerations of exploring and potentially interacting with other life forms. The mere presence of such a planet invites us to ponder our solitude or kinship in the cosmos, potentially reshaping human consciousness and our philosophical outlook on life, existence, and the universe at large. Next steps in research. Building on the groundbreaking discovery of Gliese 163c, the scientific community is buzzing with plans for future missions aimed at delving deeper into this potentially habitable exoplanet. These ambitious missions are designed not only to confirm the preliminary findings about the planet's environment, but also to explore its atmosphere in much greater detail. One of the primary objectives is to analyze the atmospheric composition and look for signatures of gases like oxygen and methane that could indicate biological processes. Another focal point of upcoming missions will be to measure Gliese 163c's temperature gradients and seasonal variations, providing insights into its climate systems. This will help scientists understand whether conditions on the planet could support liquid water, a crucial ingredient for life as we know it. By deploying advanced spectroscopy and imaging techniques, these missions will capture high-resolution data, offering a clearer picture of the planet's surface and potential weather phenomena. Furthermore, astronomers hope to determine the planet's mass with greater precision. This is essential for understanding the planet's gravitational pull and its effect on potential atmospheres. Each piece of data brings us one step closer to answering the tantalizing question: could Gliese 163c be a second home for humanity, or perhaps already home to its own form of life? Through these efforts, we seek not just to discover, but to profoundly understand what lies beyond our solar system. Learning from Gliese 163c. The discovery of Gliese 163c opens up a wealth of educational opportunities and has the potential to significantly boost public interest in astronomy and exoplanetary science. As educators integrate this new information into curriculums, students and the public alike can experience firsthand the thrilling evolution of our understanding of the universe. The concept of habitable exoplanets, such as Gliese 163c, provides a concrete example of how theoretical astrophysics impacts real-world science and stokes curiosity about life beyond Earth. This discovery also serves as an excellent tool for engaging the public in science. Media coverage and popular science content that discuss Gliese 163c can help demystify the process of scientific discovery, making the field of astronomy more accessible and appealing to a broader audience. It allows for interactive discussions, workshops, and potentially even citizen science projects where amateurs can contribute to ongoing research. The excitement generated by such findings can lead to increased funding and support for further space exploration, ensuring that the study of exoplanets remains a dynamic field at the forefront of scientific inquiry. Advanced scientific theories and models. The exploration of Gliese 163c has catalyzed the development of new scientific theories and models that aim to decode the complex environments of distant exoplanets. As astronomers analyze the data gathered by the James Webb Space Telescope, they are beginning to challenge and expand existing models of planetary habitability. For instance, the traditional model that categorizes a planet's potential for life based on its distance from the star is being nuanced with more complex variables such as atmospheric composition, magnetic fields, and orbital stability. These refined models consider how the unique characteristics of Gliese 163c, like its atmospheric chemistry and potential geothermal activity, could support life in ways that differ from Earth. The study of this exoplanet also allows scientists to test theories of planet formation and evolution in the context of different star systems. This not only enriches our understanding of how planetary systems develop, but also widens our search criteria for life-sustaining planets across the galaxy. By integrating observations from Gliese 163c into broader astrophysical models, we are on the brink of potentially discovering new types of habitable environments, fundamentally shifting our understanding of where life could exist in the universe. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
What a feast of astronomical activity. These gigantic black holes lurk at the center of galaxies. We have one right in the center of the Milky Way galaxy.
That's right. Time and space are like a fabric, like rubber, like a trampoline net. However, if you stretch the trampoline net so much, it can rip, perhaps. And perhaps you can turn this trampoline net into a pretzel and allow yourself to go backwards in time.
We physicists have waited 100 years since 1916 for this photograph.
For over a century since Einstein first predicted their existence in 1916, the scientific community and enthusiasts alike have been captivated by the allure of capturing an actual photograph of a black hole. These cosmic giants, powerful beyond comprehension yet invisible to the naked eye, stir both awe and mystery in our quest for understanding the universe. As we explore these massive beasts of the cosmos, we delve into how something so immensely powerful can remain virtually unseen, hidden within the very fabric of space-time itself. Join us as we uncover the secrets of these mysterious phenomena.
Now we've got it in the bag. We've actually photographed the silhouette, the shadow of a black hole. But that's just the
historical context and theoretical foundations. Albert Einstein's groundbreaking theory of general relativity in 1916 revolutionized our understanding of gravity and the cosmos, predicting phenomena that even he could barely imagine, including black holes. These theoretical voids in the fabric of space-time, where gravity's pull is so strong that nothing, not even light, can escape, remained a mathematical curiosity for decades. It wasn't until the 1960s that black holes shifted from theoretical constructs to observable realities. Astronomers studying the Cygnus constellation observed a blue star emitting unusual X-rays and behaving erratically around an invisible partner. This led to the discovery of Cygnus X1, a compelling candidate for a black hole, providing the first physical evidence that these cosmic behemoths were not just theoretical fantasies, but real astronomical entities in our universe. First discovery and characteristics of black holes. The story of black holes took a dramatic turn with the discovery of Cygnus X1. In the 1960s, astronomers studying the Cygnus constellation were intrigued by an unusually bright blue star emitting X-rays at an extraordinary rate. This was no ordinary celestial body. It was a stellar phenomenon behaving in ways that defied initial understanding. Further investigation revealed that these X-rays were not just emanating on their own, but were being intensely pulled into a nearby invisible object, which we now know as a black hole. This discovery was pivotal because it provided the first concrete evidence of black holes' existence, confirming Albert Einstein's theoretical predictions. Cygnus X1 exhibited properties that were both fascinating and terrifying. It shone with a luminosity about 14 times that of our Sun, yet its gravitational pull was so strong that not even light could escape it, rendering the black hole invisible and justifying its name. This immense gravitational force is crucial for understanding why black holes are such a significant find in the cosmos. They are not merely vacuums in space, but regions where gravity reshapes the very fabric of reality. This blend of visible indicators and invisible forces made Cygnus X1 a landmark in astronomical studies and sparked a renewed interest in probing deeper into the nature of black holes, research evolution, and modern understanding. Over the decades, our understanding of black holes has transformed dramatically. From theoretical predictions to tangible evidence, The journey culminated in a groundbreaking moment in 2021 when scientists captured the first clear photograph of a black hole located in the M87 galaxy. This image wasn't just a snapshot. It was a major leap in cosmic photography achieved by linking telescopes worldwide to create a planet-sized interferometer, which provided the necessary resolution to see the unseeable. The photograph itself revealed much more than expected. It gave us a direct look at the event horizon, or the point of no return, where gravitational pull becomes so strong that not even light can escape. This allowed astronomers to confirm several theoretical predictions about black holes' behavior and structure. By observing the glowing gas orbiting at the edge of the event horizon, researchers could measure the black hole's massive influence on its surroundings, offering new insights into how matter behaves in such extreme environments. This not only validated some of Einstein's predictions about general relativity, but also opened new avenues for understanding the fundamental laws of physics in the most extreme conditions known in the universe. The layers of a black hole. Diving deeper into the anatomy of a black hole reveals a complex structure composed of distinct layers, each playing a critical role in its function and behavior. The outermost layer, known as the event horizon, is famously termed the point of no return. It marks the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. This layer defines the visible outline of the black hole and acts as a gateway to its mysterious inner workings. Moving closer to the core, we encounter the photon sphere. This is a not-so-well-known layer where gravity is so strong that photons, particles of light, are forced into orbital paths around the black hole. Here, light bends around the black hole in a mesmerizing cosmic dance, creating loops of brilliant light that can sometimes be observed with sophisticated telescopes. The photon sphere is crucial for astronomers trying to see and study black holes indirectly by observing how light behaves in this extreme environment. At the very heart of a black hole lies the singularity, a point where the laws of physics as we know them break down. In this region, matter is crushed to infinite density, and the gravitational pull is infinitely strong. The singularity represents one of the greatest mysteries in modern physics. It's where our understanding of gravity, space, and time is challenged, and where current theories reach their limits. Each layer of a black hole, from the event horizon to the singularity, not only contributes to its intriguing nature, but also offers a unique playground for testing the theories of physics in extreme conditions. The nature and dangers of black holes. Black holes are not just fascinating scientific phenomena, they are also incredibly dangerous regions of space. At the heart of their danger is their intense gravitational pull, a force so strong that nothing, not even light, can escape once it crosses the event horizon. This boundary marks the point of no return. For any object unfortunate enough to get too close, the outcome is both dramatic and fatal. This leads us to the gruesome concept of spaghettification. Imagine you're falling feet first into a black hole. The gravitational pull on your feet would be significantly stronger than on your head, stretching you longer and thinner like spaghetti. This stretching happens because different parts of your body experience different intensities of gravity. Eventually, this effect becomes so extreme that it tears apart anything caught in its grasp, atom by atom. The perils of black holes extend beyond the immediate destruction of material objects. Their presence can disrupt nearby stellar environments, drawing in and accumulating gas, dust, and other celestial debris in a swirling accretion disk. This accumulation can lead to energetic emissions and powerful jets that reshape their cosmic neighborhood. Thus, the very nature of black holes as regions of extreme gravity makes them not only fascinating to study, but also incredibly hazardous to anything within their reach. Recent photographic breakthroughs. In a groundbreaking achievement, scientists have recently managed to capture the first clear images of a black hole, specifically the M87 black hole. This monumental event in astrophysics not only confirms the existence of black holes, but also allows us to peek into the dynamic processes that govern these enigmatic features of our universe. By stitching together multiple photographs taken over several nights, researchers have developed a more comprehensive view of the black hole structure. These images reveal fascinating details about the black hole's behavior, particularly how matter and light behave around this extreme gravitational force. This insight is crucial as it helps scientists understand the accretion processes and the emission of powerful jets that extend thousands of light years into space. The ability to visually observe these phenomena provides unprecedented information, transforming our theoretical knowledge into tangible, observable facts. This data is vital for testing the limits of our current physical theories and potentially guiding us towards new discoveries in black hole dynamics and the fundamental laws of physics. Black hole theories and spinning black holes. In 1963, Roy Kerr revolutionized our understanding of black holes with his groundbreaking model that described not just any black hole, but those that spin. This concept introduced us to the idea of rotating black holes, which differ significantly from the non-spinning versions predicted by earlier theories. Kerr's model proposes that the space around these spinning black holes twists along with them, leading to the formation of something known as the ergosphere. This region, lying just outside the event horizon, is where the effects of the black hole's spin are most pronounced. Matter and radiation can enter the ergosphere and receive energy from the black hole's rotation, potentially being flung out at great speeds. The implications of Kerr's model stretch even further with the theoretical possibility of the Einstein-Rosen bridge, commonly referred to as a wormhole. This hypothetical feature suggests a tunnel-like pathway through space-time, facilitated by the unique structure of spinning black holes. Theoretically, these bridges could connect two distant points in the universe, or potentially link to parallel universes. While the existence of such wormholes remains speculative, the discussion it sparks among physicists and the general public alike continues to fuel both scientific inquiry and popular fascination with the cosmos. Wormholes and interstellar possibilities. Wormholes capture the imagination as potential shortcuts through the vastness of space-time, offering hypothetical routes that could connect distant or even parallel universes. Derived from Einstein's equations, these intriguing structures are theorized to form tunnels between disparate points in the cosmos, potentially allowing for instantaneous travel across astronomical distances. However, the science behind wormholes is fraught with challenges. Current understanding suggests that while they may theoretically exist, wormholes would likely be highly unstable, collapsing too quickly for anything to pass through without extraordinary amounts of negative energy, something not currently understood to exist in the necessary quantities. This instability has led many scientists to approach the concept of practical wormhole travel with skepticism, maintaining a cautious perspective on the feasibility of using these cosmic phenomena as pathways for interstellar travel. Despite these hurdles, the study of wormholes continues to be a vibrant area of theoretical physics, pushing the boundaries of our understanding of the universe. Superstring theory and its implications. Superstring theory offers a groundbreaking perspective on the unification of the universe's most fundamental forces. This theory suggests that what we perceive as particles are actually tiny, vibrating strings, each resonating at specific frequencies. Unlike traditional particle physics, superstring theory requires a universe with 10 dimensions, far beyond the 4 dimensions of space and time that we experience daily. These additional dimensions aren't just theoretical quirks. They are essential for the mathematics of the theory to work properly, providing a framework that could potentially explain every force and particle in the universe. This bold idea not only bridges the gap between Einstein's theory of general relativity, which governs the cosmos at the largest scales, and quantum mechanics, which reigns over the smallest, but it also offers explanations for phenomena that otherwise defy classical explanations. For instance, superstring theory could elucidate the nature of black holes, which challenge our understanding of both gravity and quantum mechanics. By viewing these cosmic puzzles through the lens of superstring theory, physicists hope to unlock answers to some of the most profound questions about the structure and origins of the universe, experimental challenges, and theoretical developments. Studying black holes presents unique challenges to scientists, primarily because these cosmic phenomena do not emit light, making them invisible to traditional observation methods. Researchers must instead rely on indirect methods, such as observing the gravitational effects black holes have on nearby stars and gas clouds. This indirect approach adds layers of complexity and uncertainty to their studies. Further complicating the study of black holes is the theoretical framework of superstring theory. This advanced theory suggests that all fundamental particles are not point-like dots, but rather tiny vibrating strings. Superstring theory is a leading candidate in the quest to unify Einstein's theory of general relativity with quantum mechanics. However, it posits the existence of 10 dimensions, 6 beyond the 3 spatial dimensions and 1 time dimension we experience daily. These extra dimensions are theorized to be compact and rolled up so tightly that they are beyond our current capability to observe directly, posing a significant hurdle for empirical validation. The unstable properties of theoretical constructs like wormholes add another layer of complexity. Wormholes, predicted by the equations of general relativity under specific conditions, are passages through spacetime that could, in theory, connect distant parts of the universe or different universes altogether. However, the inherent instability of these wormholes and the extreme conditions likely found at their entrances, such as intense radiation and crushing gravitational forces, make them difficult to study or even confirm their existence scientifically. These challenges mean that much of what we understand about black holes and related phenomena remains speculative, relying on advancing theoretical physics and improving observational technologies to bring these cosmic mysteries into clearer view. The Big Bang and beyond in string theory. String theory offers a fascinating twist on the Big Bang theory, suggesting that what we perceive as the universe's beginning might actually be far more complex. According to this theory, our universe could potentially be the product of 2 separate universes colliding, or a universe birthing another, akin to a cosmic child emerging from its parent. This interconnection between universes is conceptualized through what's known as wormholes, which are theorized as cosmic tunnels linking disparate parts of the universe or even different universes altogether. The implications of this are staggering. If wormholes are real and stable enough to connect different realms of space-time, our current understanding of our place in the cosmos could be fundamentally altered. It raises the possibility that what we consider black holes might actually be gateways or bridges to other dimensions or distant parts of our universe. This leads to an even more bewildering possibility. Could our entire observable universe be inside a black hole located in a much larger universe? Such a scenario would redefine concepts of beginning and end and what it means to exist in this universe. As we continue to explore these profound questions, the mysteries of the cosmos keep our curiosity piqued, pushing the boundaries of our understanding of the very fabric of reality. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Looks at going to the moon one day and to Mars, and to get to Mars, they're going nuclear.
Imagine a world in which we are no longer limited by space and can traverse the enormous cosmic distances that previously seemed unbridgeable. Imagine spacecraft traveling faster than the speed of light as they dart across the stars, a concept that piques our curiosity and fuels our desire to explore beyond Earth. Science fiction no longer exists in this domain. Scientists are about to make discoveries that could lead to travel faster than the speed of light. We are on the verge of transforming the fantastical into the real, capable of stretching the boundaries of space and time and exploring theoretical possibilities that defy basic physics.
We call the action, which is to do with the mass of the particle and the time and the distance, so you basically calculate these little quantities.
But how much closer are we really to crossing this last obstacle? To what extent is science fiction already becoming science fact? Imagine being able to travel through space faster than the speed of light by boarding a spacecraft that looks like it belongs in your favorite action film. Once limited to fiction, this ambition is becoming more and more true thanks to the idea of warp drives, a speculative idea that might completely change space travel. The fundamental tenet of this project is a daring rejection of one of the most widely accepted theories in physics. Einstein's claim that nothing can travel faster than the speed of light. In accordance with Einstein's theories of relativity, an object's mass increases exponentially as it gets closer to the speed of light and needs an endless supply of energy to move forward. Humanity has long been forced to travel across the vast reaches of space at the glacial rate of conventional propulsion because to this barrier, which appears to be insurmountable. This brings us to the Alcubierre drive, an idea that originated in physicist Miguel Alcubierre's academic endeavors rather than science fiction. Alcubierre put up a method that bends space-time itself rather than trying to exceed the cosmic speed limit, drawing inspiration from the visionary leaps of science fiction. Imagine compressing space in front of a spaceship and extending space behind it, all while enclosing it in a bubble of flat space-time. By staying in a pocket of space unaffected by relativity, this manipulation allows the spaceship to travel ahead and ride the wave of warped space-time at effective speeds faster than light. Unquestionably enchanting, the Alcubierre drive offers a ticket to the skies. However, there are many theoretical and practical obstacles in the way of turning an idea into reality. Because the drive needs exotic matter or negative energy, it operates at the edge of physics, where the existence of such materials is still up for debate. Furthermore, this innovative kind of transportation is beyond the reach of existing technology due to the enormous amounts of energy required to control space-time on this scale. Warp drive technology, in spite of difficulties, symbolizes human inventiveness and our unwavering desire to explore, signaling the beginning of star-crossing expeditions as a tribute to our boundless potential and the ever-expanding boundaries of knowledge. Historical leap, the Concorde and its legacy. The Concorde is remembered in the annals of aviation history as a shining example of human inventiveness and the relentless pursuit of breaking boundaries. This supersonic passenger plane accomplished exploits that were previously only found in science fiction, completely redefining what it meant to fly over the sky. The Concorde, with its streamlined appearance and powerful engines, cut the time it took for traditional jet travel in half and made far-flung continents accessible in just 3.5 hours from Paris to New York. Nevertheless, despite its grandeur and speed, the Concorde had many drawbacks. Its only options were over the ocean, far from populated regions where the noise may disturb people due to the loudness of its engines and the sonic booms it left behind. Its retirement was also a result of its high operational expenses and the financial difficulties of maintaining such speed for commercial travel. But Concorde's legacy stood untarnished, marking a significant turning point in the race to conquer the sky and push the envelope of what was thought to be feasible. Curiosity and inspiration from the Concorde caused humanity to turn its attention from the skies to the stars, where they began investigating warp drives and space-time bending in an attempt to conduct interstellar travel, pioneering faster-than-light travel. Humanity is on the verge of making science fiction's fantasies a reality through our mission to colonize the vast reaches of space. Science and fantasy alike have long been enthralled with the notion of warping space and time itself to accelerate our craft faster than the speed of light in the cosmos. Experts in theoretical physics are now closely examining this idea, which looks like it could have been lifted from a science fiction book. It's amazing to see how the world of science fiction has impacted and inspired actual scientific investigations into the viability of warp drives. Interstellar travel has become a reality thanks to shows like Star Trek and the imaginative writings of authors like Gene Roddenberry and John W. Campbell. These works have also introduced the concept of the warp drive, a fantastic engine that can propel a spaceship faster than the speed of light to a wider audience. What was previously only a whimsical thought in the minds of artists has now provoked serious debates and theoretical investigations within the scientific community. In the 1990s, physicists began to view the ideas outlined by Einstein's theories as puzzles to be solved or opportunities to be taken advantage of, rather than as impassable obstacles that would never be overcome. This marked the beginning of the move from fiction to theoretical possibility. The difficulty was obvious. Could we not figure out a method to bend space-time itself, making shortcuts that would let us jump across cosmic distances in the blink of an eye, given that nothing can move faster than light within it? This bold inquiry has sparked an intriguing voyage of exploration that is expanding our knowledge of the cosmos and our role in it. Combination of science fiction, creativity, and modern research in the field of faster-than-light travel blurs the boundaries between the feasible and the impractical, bringing us one step closer to fulfilling the dream of space travel. Warp drive, from fiction to theoretical possibility. The transition from fiction to theoretical potential in the field of space travel frequently starts with an imaginative spark kindled by the stories we tell. Science fiction was full of ideas like warp drive, which imagined a time when people could travel across space faster than light and even faster than the speed of sound. Once limited to the pages of books and movie screens, this concept has drawn interest from scientists and grown into a ray of hope for intergalactic travel. How do we overcome the colossal barriers that stand in our way is just as important as can we when it comes to the task of traveling faster than the speed of light. Undoubtedly, energy is the most critical of these impediments. The speed of light is the ultimate speed limit of the cosmos according to the equations governing modern physics, which are based on Einstein's theories of relativity. According to our current understanding of physics, an endless amount of energy would be necessary to push an item at the speed of light, a frightening prospect that puts such undertakings in the realm of the impossible. Nonetheless, scientists are starting to look for answers on the outer edges of theoretical physics after being motivated by the creative leap of science fiction. There is some hope in the warp drive hypothesis, especially in the model put forth by physicist Miguel Alcubierre. Rather than challenging Einstein's speed restriction, Alcubierre's model suggests a workaround. If space travel isn't possible at a faster speed than light, then perhaps space can be made to move. A warp bubble that propels a spacecraft at essentially faster than light speeds might theoretically be created by shrinking space in front of the vehicle and expanding it behind. Negative energy or negative mass, which are not present in nature and whose very presence is considered exotic, is needed for this approach of bending space. The obstacles to developing a warp drive are enormous and go beyond energy needs to include the technical difficulties of modifying spacetime itself. How can the negative energy needed to create a warp bubble be produced and controlled? Which substances are resistant to the strains involved in this kind of operation? Crucially, how can we guarantee the viability and safety of traveling faster than the speed of light for the cosmos as a whole, as well as the courageous individuals aboard these cutting-edge ships? The distinction between science and fiction becomes increasingly hazy as we go across space, as evidenced by the development of the warp drive from theoretical concept to working machine, the Alcubierre drive and beyond. Miguel Alcubierre, a physicist, came up with the intriguing theoretical idea of the Alcubierre drive, which would bend space-time itself and send humanity rocketing into far-off stars almost instantly. It's like riding waves of space-time, only instead of traveling through space, we can change space itself, making it possible for us to travel faster than light and across great distances. But even as the prospect of interplanetary travel shines brightly in our eyes, there are great obstacles in our way. The most difficult riddle, the amount of energy needed. According to theoretical calculations, producing the warp bubble would require mass and energy comparable to that of Jupiter, which is an enormous undertaking that beyond both our existing technological capacities and physics knowledge. Furthermore, the drive is predicated on the presence of negative matter, a material whose repellent gravitational qualities defy common sense. Although the theoretical foundations of negative matter provide some optimism, its elusiveness has kept it just out of reach for science, existing only in the intricate mathematical formulas of theoretical physics rather than in observable reality. The universe's boundless potential is revealed as scientists negotiate the challenges of warp drive technology and the hunt for negative matter on this difficult but inspiring adventure to revolutionize space travel. Innovations in warp drive research. Eric Lentz and Harold Sonny White have made significant contributions to the dynamic field of warp drive research, which is devoted to connecting science fiction and reality. Using solitons, self-maintaining warp bubbles. Dr. Lentz, a theoretical physicist at the University of Göttingen, presents a novel approach to traveling faster than light. This method avoids the traditional requirement for exotic matter and instead suggests a workable solution powered by positive energy densities already within our reach. In the meantime, the Limitless Space Institute is led by Dr. Harold Sonny White, a former NASA employee who has played a key role in advancing the theoretical idea of warp drives toward real-world testing. The finding by Dr. White of naturally occurring small warp bubbles in the Casimir cavity, which is formed by pressing two metal plates together in a vacuum, suggests that it may be possible to enlarge these structures to a size suitable for use in space exploration. This finding not only validates the warp drive theory, but also provides fresh directions for future investigations into the creation and manipulation of these warp bubbles. Dears, Lentz and White are making great strides toward enabling access to the stars through inventive physics and engineering with their groundbreaking work in warp drive development, which is closing the gap between the ideals of interstellar exploration and reality. Reality check. Our current capabilities. The boundaries between the realistic and the fantastical are frequently blurred in the field of space exploration, particularly when discussing the idea of traveling through space at warp speed, a notion that was previously only seen in science fiction books. We are captivated by the idea of reaching the stars during our lifetimes by surpassing the speed of light, the cosmic speed limit. For the time being, though, let's return to the present and the enormous, incomprehensible stretches of space that confront us, pushing the boundaries of our technical capabilities to the absolute maximum. The Parker Solar Probe, our fastest spacecraft to date, reaches an astounding 700,000 kilometers / a small fraction of the speed of light. To put this into perspective, it would take more than 6,500 years to travel to Proxima Centauri, our nearest star neighbor, even at this astounding speed. We imagine speeds that can exceed the speed of light when we discuss warp drives and folding space, which would enable us to travel across galaxies in an instant. However, the sobering truth of our current state of affairs presents a different image. Not only is the immensity of space intimidating, but it also serves as a sobering reminder of our small place in the cosmos. The distances involved are enormous, mind-boggling, not simply huge. Furthermore, our most sophisticated rockets and probes hardly even scrape the surface of the cosmic ocean, despite the tantalizing prospect of warp drive shortcuts presented by our theoretical models of spacetime. This sobering reality check is supposed to strengthen our commitment rather than lower our spirits. Every generation builds on the foundations set by the one before it, pushing the envelope of what is possible even farther. With aspirations of traveling faster than the speed of light, we stand on the shoulders of giants today and gaze out into space. However, it's crucial to keep in mind that the slow, sometimes agonizing advancements in knowledge and technology are what set us on our path to the stars. We pay tribute to our current space pioneers who, with every tiny but important step, overcome obstacles to bring the far stars within reach, bringing in a new period of unheard of growth, creativity, and discovery as we look forward to the days of warp drives and interstellar travel. Mars, humanity's next frontier. Looking beyond Earth, Mars represents the next great step forward for humanity on its cosmic voyage. Scientists, dreamers, and adventurers have all been enthralled with this mysterious crimson planet, shrouded in mystery and charm. In addition to being a monument to human tenacity and inventiveness, our mission to colonize Mars serves as a link to comprehend our place in the cosmos. The narrative of nations keen to leave their marks on space exploration history is one of victories and losses along the way to Mars. In an effort shrouded in secret, the Soviet Union was the first to reach out toward Mars. Despite its great ambitions, the Mars 1 mission ended in quiet when contact was lost. However, this did not dampen the spirit of inquiry. After it came Mars 2 and Mars 3, which, despite the latter's brief communication, were humanity's first visits to the Martian surface. In the present day, the terrain of Martian exploration is a patchwork of global endeavors. With the help of its Curiosity and Perseverance rovers, the United States has shed light on Mars geology and the possibility of extraterrestrial life. Equipped with state-of-the-art tools, these pioneering mechanical people navigate the Martian landscape and reveal mysteries that have been hidden for ages. Europe has also turned its attention to Mars, joining forces with Russia to launch the ExoMars mission with the goal of deciphering Martian methane and any biosignatures. The mission highlights a global desire to reach beyond our earthly bounds, even in the face of geopolitical tensions and the challenging conditions of space travel. The story of Mars exploration embodies the human spirit's unwavering quest for knowledge and our ability to dream big, as it captures the evolution of international rivalries into partnerships, technological achievements, and the indomitable human spirit. Soviet Union's secret success and the race to Mars. A covert race to the stars took place in the midst of the Cold War, out of the public sight. Driven by its spirit of innovation in space research, the Soviet Union set out on a quest that would subtly leave its mark on the history of interplanetary exploration. The Soviet Union had the audacity and the covertness to aim higher, towards the red soil of Mars, while the rest of the world was focused on the Moon. A significant, though little known, chapter in space history began in 1971. For the first time ever, a successful landing on the red planet was accomplished by the Soviet spacecraft Mars 3. There was, however, hush surrounding this incredible achievement. The expedition was decided to remain secret when the probe, having only communicated data back to Earth for a few seconds, failed due to the harsh Martian environment. The Soviet Union had anticipated a success that would eclipse the American moon landings, but instead, they witnessed a quiet victory that was only acknowledged by a select group of people in the upper echelons of Soviet politics and science. This covert accomplishment highlighted the fierce rivalry that defined Cold War-era space exploration. Every superpower desired scientific advancement as much as the enhanced geopolitical status that accompanied every significant space exploration achievement. While not as well known as their American counterparts, the Soviet Mars missions demonstrated a strong dedication to expanding human knowledge and capabilities. However, the quiet surrounding the Soviet Union's Martian experiments also reflected the larger character of the space race, which was characterized by amazing achievements made in the shadow of competition. The Soviet Union's covert Mars mission revealed a new chapter in space exploration history, offering a platform for not just rivalry, but also exploration and amazement beyond our planet's boundaries. The enduring legacy of the covert Cold War Mars missions demonstrates human ambition and curiosity, serving as a constant reminder of the infinite potential of space and motivation for our ongoing exploration of the unknown. The future of interstellar travel and Mars colonization. The prospects for interstellar travel and Mars settlement are endless as we approach the dawn of a new age in space exploration. The greatest minds in theoretical physics are currently delving into the unrelenting quest for faster-than-light travel, which was formerly limited to science fiction books. Visionaries such as Miguel Alcubierre have promoted the idea of bending space-time to our whim, which offers an alluring portal to the stars. Researchers like Durst, Eric Lentz, and Harold Sonny White are working hard to make the warp drive a reality, and it is no longer just a sci-fi fantasy. These developments portend a time when light-years-long travel distances could be completed in the blink of an eye. Concurrent with the aspiration to surpass the speed of light is the grand project of settling on Mars. For many years, the red planet has captured the attention of people because to its bleak beauty and possibility of fresh starts. In addition to offering priceless insights into the temperature, geology, and possibility of life on Mars, recent missions have established the foundation for human habitation. The combination of private companies like SpaceX, led by Elon Musk, and international space agencies is driving the dream of Mars colonization ahead. Musk hopes to establish a long-term human presence on the planet during our lifetimes. This joint effort represents a cosmic giant leap for humanity, similar to the evolution from hunter-gatherer tribes to agricultural civilizations. Still, the trip to Mars is only the start. The possibility of exploring space beyond Mars and into the larger galaxy is becoming more and more realistic as our knowledge of science and technology advances. The finding of exoplanets in habitable zones around far-off stars has created new opportunities for research and possibly even habitation. These celestial bodies might provide new places for humans to live, assuring our survival and the continuance of our galactic exploration and learning endeavors. In conclusion, the prospect of Mars settlement and interstellar travel serves as a constant reminder of our enduring urge to explore the unknown, in addition to serving as a monument to human creativity and tenacity. The opportunities are endless as we approach the edge of this new territory. The stars are lighthouses pointing us in the direction of our destiny amid them, not merely spots of light in the night sky. Although the road ahead is full of obstacles, we approach it with hope and the unwavering spirit of discovery that makes us who we are. Not on Earth, but in the dusty red soil of Mars and beyond, into the wide, unexplored reaches of our cosmos,
lies the next chapter in the history.
Entire universe will be aware of this one explosion.
It's very unstable. It's about to explode.
No, give me the timescale for that.
The thing is, it could be tomorrow.
So imagine looking on the horizon and sunrise is half the sky.
The red supergiant star known as Betelgeuse or Betelgeuse is a striking sight in the night sky because of its vivid ruby-red color and prominent placement in the well-known constellation Orion, where it represents the hunter's shoulder. This star is one of the brightest stars that can be seen from Earth, which makes it noteworthy not just for its brightness but also for its important place in the star charts of many ancient societies. With its visibility, Betelgeuse, the 9th brightest star in our sky overall, becomes a prominent highlight in the winter sky for observers in North America, Europe, and Canada. The star is particularly notable for its brightness variability and massive size, which, along with its reddish tint, add to its significance and fascination for both amateur and professional astronomy. Due to an unexplained and noteworthy dimming event that occurred in late 2019 and early 2020, the astronomy world was abuzz with discussions about Betelgeuse. Betelgeuse, which is typically among the brightest stars that are visible from Earth, suddenly became less luminous, raising the possibility that the star is approaching the end of its life cycle and may explode as a supernova. This occurrence caught the attention of both amateur and professional stargazers because it was so distinct and noticeable that it could be seen with the unaided eye. Betelgeuse's dimming was more than a slight variation in brightness. It was a significant alteration from its typical light patterns. Although the star's brightness has fluctuated in the past, this period's observed dimming was unparalleled in both its scope and speed. Across the globe, astronomers trained their telescopes on Betelgeuse, curious to see if these modifications hinted at a more profound and potentially disastrous metamorphosis. The behavior of such a well-studied star straying from its expected path was a riddle that may potentially reveal fresh insights into the life cycles of red supergiants. Therefore, this global interest went beyond academic pursuits. Beyond merely observing a star fade, this dimming raised concerns regarding the timing of supernova and the mechanisms that precede these celestial explosions. The entire world speculated about whether they were about to see a once-in-a-lifetime astronomical event as they watched and waited. Because Betelgeuse pulses measuring its size and distance from Earth is a major issue for astronomers. This red supergiant star fluctuates in size throughout time, never being constant in size. This diameter variety makes it challenging to get exact measurements. The optical emissions from Betelgeuse pulse, changing in hue and intensity as it gets farther away from the center, a phenomenon called limb darkening. Measurements are made more difficult because of this effect, which results in a star without a definite edge. The difficulties don't end with determining its dimensions. Determining Betelgeuse's distance from Earth is likewise quite challenging. Its distance is currently estimated by astronomers to be between 430 and 724 light-years away. However, as new techniques and technologies are developed, these estimates could vary. Despite these difficulties, sophisticated telescopes have been crucial in revealing fascinating information about the star. For example, astronomers have found that Betelgeuse is surrounded by at least 6 shells. These shells, which are composed of material expelled from the star, offer vital information about the mass loss mechanisms and life stages of the star. Every shell denotes a distinct stage in the mysterious supergiant's life cycle and marks important moments in its evolutionary history. In the distant future, Betelgeuse may burst into a supernova which would drastically change how it appears in the night sky. Supernovas, which occur when a star reaches the end of its life and bursts, unleashing enormous amounts of energy, are among the most powerful phenomena in the cosmos. In Betelgeuse's instance, the core gets unstable as it goes from burning hydrogen to fusing heavier atoms like helium, carbon, and finally iron. This devastating explosion is caused by the star's iron core collapsing under the force of its own gravity when it can no longer support the mass of the star. It is anticipated that Betelgeuse will outshine all other stars in our galaxy put together when it goes supernova, providing a show that may even be visible during the day. The reason for this brightness is that the supernova explosion produces an incredible quantity of energy, which momentarily approaches the luminosity of a whole galaxy. Even with this spectacular spectacle, Earth is not directly threatened by the event. The distance between Betelgeuse and Earth is approximately 600 light-years, so any consequences from the explosion, such as radiation and cosmic particles, will evaporate before they get to Earth. That being said, life on Earth will not be impacted by the supernova, even though it will present a breathtaking sight for stargazers and could prove to be a significant event in scientific research. Because of this safe distance, we have the rare opportunity to study and monitor the supernova without running any risk, which has allowed us to learn important things about the dynamics of these explosive occurrences and the life cycle of stars. Betelgeuse offers a rare view into the life and tumultuous maturation of a star. Similar to other stars, Betelgeuse was first powered by the nuclear fusion of hydrogen atoms in its core. This process, when hydrogen nuclei combine under high pressure and temperature, generates helium and releases considerable energy in the form of light and heat. Depending on the star's size, this phase of its existence can last millions or billions of years. With age, Betelgeuse's hydrogen fuel ran out, signaling the start of the next stage of its stellar life. The star then began fusing heavier elements like carbon with helium. This change in nuclear fusion material is a crucial stage in a star's life cycle that affects the structure and energy output of the star. This meant that Betelgeuse would experience the normal red giant traits of size growth, surface temperature cooling, and brightness variation. As the fusion process continues, heavier elements like neon and eventually iron are added. Iron fusion, however, absorbs energy rather than producing it like the previous reactions did. As a result, the star becomes unstable since there isn't enough external pressure to oppose the strong gravitational attraction drawing the star inward. With no fusion energy released to sustain its external pressure, Betelgeuse is on the verge of a catastrophic collapse, which could indicate the beginning of a supernova explosion. A supernova, the dramatic and violent conclusion to a star's life, is preceded by this process of fusing lighter elements to create iron in the core. When Betelgeuse runs out of nuclear fuel, it will eventually collapse under the force of its own gravity, exploding its outer layers and briefly outshining entire galaxies in the cosmos. This is the ultimate celestial event. In addition to bringing Betelgeuse's life cycle to a conclusion, this spectacular finale seeds future stars and planets in the universe by adding heavier elements. Astronomers can thus get a unique look into the intricate and dynamic processes of star evolution by studying Betelgeuse. When we examine the hypothetical supernova of Betelgeuse, one of the first things that comes to mind is the impact it would have on Earth. Despite the spectacular nature of such an occurrence, the good news is that Betelgeuse's distance from our planet puts it in a safe zone. From an astronomical perspective, Betelgeuse is positioned between 430 and 724 light-years distant, which is simply too far away for Earth to be at risk of being struck by supernova consequences. For a supernova to truly endanger the safety of our world, it must be located closer than 50 light-years away. If large quantities of the cosmic radiation and energetic particles produced by a supernova reach Earth, they may be dangerous. But before they could disrupt our biosphere, these would disperse or be absorbed by interstellar medium at the distance of Betelgeuse. Undoubtedly, the spectacle of Betelgeuse going supernova would be an astronomical event of a lifetime. When it explodes, it might become one of the brightest things in the sky, outshining even the full moon and visible during the day. In addition to being aesthetically pleasing, such a display would provide a rare chance for scientific research and teaching, offering new perspectives on the dynamics of supernova and the life cycle of stars. In conclusion, Earth would not end in calamity, even though Betelgeuse's supernova would be an amazing sight. Rather, it would be a secure, captivating exhibition of the forces that mold our cosmos. This gives us comfort in knowing that despite the tremendous forces at work in space, our planet is safe from such far-off celestial events because of the vast distances that separate us from even the most violent stellar deaths. Let's not dive deeper into the unexpected dimming of Betelgeuse. Astronomers and stargazers alike were drawn to Betelgeuse because of its sudden dimming that was noticed in late 2019. This first sparked a lot of rumors that Betelgeuse might be about to go supernova. Nevertheless, additional observations have provided an alternative interpretation that fundamentally alters our perception of the true nature of this far-off monster. There is evidence that a significant surface mass ejection, SMME, from Betelgeuse occurred, according to astronomers utilizing the Hubble Space Telescope and other observatories. There had never been anything like this in the history of stars. In other words, a sizable amount of Betelgeuse's exterior was launched into space, creating a sizable dust cloud. The star appeared to be dimming because part of the light from Betelgeuse was blocked by this cloud. This huge ejections finding was revolutionary since it offered a tenable explanation for the star's dimming other than the star's impending supernova. Furthermore, this occurrence made it possible for scientists to watch and study a brand new type of stellar behavior. Gaining knowledge about these ejections can help us understand red supergiant life cycles and the mechanisms influencing their stability and lifespan. This event serves as a reminder of the unpredictability of late-stage star life cycles and the capacity of contemporary astronomy to track and analyze far-off celestial events in real time. Betelgeuse and other red supergiants are essential to the universe, especially to the mechanisms that aid in the recycling of galactic matter. When these enormous stars approach the end of their lives, they go through a number of intricate processes that eventually cause different elements to disperse throughout the galaxy. This phenomena is essential to the development of new planets and stars. Iron is created in the core of a red supergiant star by the fusion of lighter elements into heavier ones over the star's life cycle. The star becomes unstable as the fusion processes go from hydrogen to heavier components like carbon, neon, and ultimately iron. A supernova explosion, which is caused by this instability, is so strong that it spreads the star's material far into space. Such explosions release a rich mixture of components that are essential for the development of new celestial bodies. For example, the construction of rocky planets and the evolution of life as we know it depend on the carbon and other heavy elements produced during the star's lifetime. Furthermore, the dynamics of galaxy evolution are significantly influenced by the demise of red supergiants and the supernovae that follow. By compressing neighboring interstellar gas clouds, the shock waves from these explosions can start a fresh cycle of star birth by creating new stars. This process influences the creation of star clusters and may even affect the structure of galaxies themselves, adding heavier materials to the interstellar medium and aiding in the structural evolution of galaxies. Thus, knowledge of red supergiants and their life cycles sheds light on the larger processes that shape our universe in addition to the fate of individual stars like Betelgeuse. Astronomers can better understand the intricate processes of matter recycling in galaxies by studying these star giants, which contributes to their understanding of the vast and intricate universe. Astronomical observations appear to have a bright future as we continue to solve the riddles of Betelgeuse and its life cycle. The deployment of next-generation telescopes like NASA's James Webb Space Telescope, along with other advancements in telescope technology, would significantly improve our understanding of red supergiant stars like Betelgeuse. Expected to offer previously unheard-of insights into the behaviors of stars on the verge of supernova, the James Webb Space Telescope outperforms its predecessors in terms of resolution and sensitivity throughout a larger wavelength range. This includes being able to see the star's outer layers in greater detail and pick up on minute variations in brightness and makeup. This might involve in-depth examinations of the surrounding nebula and surface mass ejections for Betelgeuse, which could reveal information about the star's mass loss and the events leading up to its ultimate explosion. These telescopes will also make it possible for astronomers to track Betelgeuse in real time, catching quick changes in its structure and brightness before the supernova explosion. The timing of Betelgeuse's explosion, which is still unknown despite our advanced technology because red supergiants are complicated objects, depends on this real-time monitoring. Not only will observational technologies help, but theoretical developments in star physics will probably improve our ability to anticipate. Through the integration of sophisticated computer models with observations from Webb and other facilities, astronomers will get a deeper understanding of the physical conditions leading to many types of supernovae and their aftermath. Combining theory and observation should allow us to predict when Betelgeuse will explode in a supernova and model the impact of that event on the interstellar medium around it. These developments pave the way for a future as brilliant and explosive as a supernova by improving our comprehension of cosmic occurrences and stellar evolution. In addition to its special place in the sky, Betelgeuse, often known as Betelgeuse, has a special role in cultural and historical tales all throughout the world. Traditionally called Alpha Orionis, this star has fascinated astronomers from prehistoric times to the present day. It is frequently shown on star charts as the hunter Orion's right shoulder. Because of Orion's significant role in Greek mythology and its adaptations in other cultures, it is intimately associated with a number of myths and stories, especially those pertaining to hunting and warriors. The Arabic term Ibt al-Jawza, which means the armpit of Orion, is where the name Betelgeuse originates. Though some academics say the name could also refer to the hand or shoulder, this translation may not fully reflect the subtleties of the term, providing further layers of interpretation to its placement within Orion. The fact that people have been fascinated with Betelgeuse since the 1st century BCE shows how important it has always been to astronomical research. Furthermore, historical accounts like those written by Greek and Chinese astronomers detail the star's color fluctuations. For example, Ptolemy, a Greek observer, described the star as ruddy, while Chinese scholars described it as yellow. These accounts imply that Betelgeuse's appearance may have changed significantly over millennia. These observations highlight the star's variable nature, implying that it was dynamic and changing before more advanced telescopes could provide a more precise image of these changes in the sky. Through these different lenses, linguistic, observational, and mythological, Betelgeuse has been a source of wonder and curiosity, illuminating both the innate human impulse to create stories about the stars that fill our night sky and the scientific drive to comprehend the universe. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Proxima B. And so what's the story? When are, and that it's Earth-like.
Yeah, so that's not what's interesting about it, because we've got plenty of Earth-like planets.
You know, one of the big news items recently was the discovery of a planet that may end up being the closest planet to us of any of them that aren't in our own solar system, Proxima B.
If it has an atmosphere, it is actually pushing up the temperature through the greenhouse effect above 0 degrees and in the liquid water habitable zone.
In the vast, swirling expanse of the cosmos, a beacon of light pierces the darkness, revealing secrets long held by the universe. The James Webb Space Telescope, humanity's most ambitious eye on the sky, ventures beyond the veil of the known, pushing the boundaries of our understanding. As it gazes upon Proxima Centauri, a mere 4 light-years away, it uncovers whispers of a world unlike any other. Proxima B. Amidst the cosmic silence, an anomaly sparks a cascade of questions, artificial lights flickering from the surface of this alien world. Could this be the evidence we've been searching for? Are we on the cusp of uncovering a civilization beyond our own?
The James Webb Space Telescope is upsetting the apple cart. All of a sudden we realize that we may have to rewrite all the textbooks about the beginning of the universe.
A quest for extraterrestrial life. For as long as humanity has gazed up at the night sky, we have been captivated by the tantalizing mystery of what lies beyond our own world. This ancient curiosity, woven into the fabric of our collective imagination, has driven us to ponder the existence of life among the stars. At the heart of this cosmic quest stands the James Webb Space Telescope, JWST, a marvel of human ingenuity and the most powerful telescope ever constructed. Launched with the promise of expanding our understanding of the universe, the JWST serves as a bridge between the dreams of our ancestors and the possibilities of our future. With its unprecedented capabilities, it peers into the depths of space, aiming to unravel the mysteries that have eluded us for generations. As it trains its gaze on Proxima Centauri, our nearest stellar neighbor, and its intriguing planet, Proxima B, we stand on the precipice of potentially groundbreaking discoveries. Could this advanced observatory, floating 1,000,000 miles from Earth, finally provide the answers to one of humanity's oldest questions? Are we alone in the universe? Observations of Proxima Centauri. In the silent dance of celestial bodies, a startling anomaly emerges from the depths of space, capturing the collective imagination of Earth's greatest minds. Within the closest star system to our own, Proxima Centauri, lies a planet bathed in mystery, Proxima B. Here, through the eyes of the James Webb Space Telescope, scientists have observed peculiarities that defy conventional understanding. These are not mere flickers of cosmic radiation or the reflective sheen of natural phenomena, but what appear to be artificial lights, shining defiantly against the backdrop of the void. This extraordinary discovery propels us into a realm of speculation and wonder, challenging our preconceptions of life beyond our solar sphere. Are we witnessing the first concrete evidence of an alien civilization? Could Proxima B be home to intelligent beings, gazing back at us across the cosmic expanse? The Search for Extraterrestrial Intelligence, SETI. In 1984, a visionary quest began to pierce the cosmic silence, a project born from the boundless curiosity of American astronomers Jill Tarter and Thomas Pearson. they launched the Search for Extraterrestrial Intelligence, SETI, ambitious endeavor aimed at capturing the faint whispers of the cosmos through spaceborne radio signals. Their goal was profound yet simple: to find evidence of civilizations beyond our own. Armed with an array of 42 radio telescopes nestled in the Californian Cascade Mountains, part of the unique Allen Telescope Array, they listened to the universe's myriad frequencies, hoping to detect a pattern, a signal, anything that might suggest we are not alone. Yet, despite their advanced technology and unwavering dedication, the past 30 years have passed without a single verifiable alien signal. The James Webb Space Telescope launched as humanity's most advanced observatory, the James Webb Space Telescope, JWST, marks a monumental leap in our quest to understand the cosmos. Equipped with an array of highly sensitive detectors, JWST embarks on a mission to explore the enigmatic realms of distant planets, casting its gaze into the cosmic distances where the secrets of the universe lie hidden. This groundbreaking endeavor not only showcases our technological prowess, but also heralds a new era in astronomical discoveries. Since the discovery of the first exoplanet 2 decades ago, astronomers have unveiled over 4,000 such distant worlds, orbiting stars far beyond our solar system. This remarkable feat suggests that our galaxy, and indeed the universe, may be teeming with trillions of exoplanets, each with its own story, potentially rewriting what we know about the possibilities of life beyond Earth. JWST's mission, therefore, is not just a journey through space, but a voyage across the frontiers of human knowledge, promising insights into the age-old question of whether we are alone in the universe. Detection techniques and challenges. The James Webb Space Telescope represents a quantum leap in our quest to uncover signs of life beyond Earth, equipped with the precision to dissect the faint whispers of distant worlds. Among its arsenal for detecting life is the search for the vegetation red edge, VRE, biosignature, a distinctive signal that terrestrial plants reflect, mixing red and infrared light, a beacon of life as we know it. This capability allows the JWST to scrutinize exoplanets in the habitable zones of their stars, hunting for similar signals that could indicate sprawling extraterrestrial vegetation. Additionally, the JWST employs spectroscopy, a technique that deciphers the chemical makeup of a planet's atmosphere by analyzing the light spectrum. As sunlight passes through an exoplanet's atmosphere, certain wavelengths are absorbed by atoms and molecules, leaving behind a spectral fingerprint. These fingerprints can reveal the presence of elements and compounds, such as oxygen, nitrogen, and carbon dioxide, which are crucial for life as we understand it. However, the challenge doesn't end with detection. Discerning the nuances between geological and biological processes that could produce similar atmospheric signatures is a complex task. Proxima B's characteristics and habitability. Nestled within the cosmic neighborhood, merely 4.25 light-years from our solar sanctuary, lies Proxima B, a planet orbiting the red dwarf star Proxima Centauri, captivating astronomers with its enigmatic nature and potential for harboring life. This intriguing world, discovered to reside in the Goldilocks zone, where conditions could be just right for liquid water, a crucial ingredient for life as we know it, presents a paradox of possibilities and challenges. Proxima B's close orbit around its star, at a distance of merely 4.6 million miles, subjects it to intense solar winds and radiation, casting doubt on the planet's ability to retain a life-sustaining atmosphere. Yet this proximity also bathes Proxima B in enough sunlight to potentially mimic the temperate conditions of Earth, should an atmosphere exist. The planet's tidally locked nature, always showing the same face to its star, suggests a world of extremes. One side perpetually basked in daylight, the other ensconced in eternal night. This unique orientation raises questions about the climate dynamics and whether conditions could allow for the stable presence of liquid water. Furthermore, the potential for strong solar flares from Proxima Centauri could further threaten the atmosphere's stability, unless Proxima B possesses a protective magnetic field akin to Earth's. Technological signatures of life. Amidst the cosmic dance of stars and planets, the James Webb Space Telescope, JWST, embarks on a quest not just to explore the vast unknown, but to decipher the very signatures of life itself. In its crosshairs is an intriguing method of detection, one that hinges on the presence of chlorofluorocarbons, CFCs, within the atmospheres of distant exoplanets. These chemicals, the byproducts of industrial activities on Earth, serve as potential harbingers of technological civilizations beyond our own. Yet, the universe is a tapestry of complexities, weaving together countless chemical processes that mimic the fingerprints of life. The JWST, with its unparalleled gaze, confronts the formidable challenge of sifting through these cosmic signatures, distinguishing the artificial from the natural, the living from the lifeless. Exploration of the TRAPPIST-1 system, embarking on an unprecedented voyage across the cosmic sea. The James Webb Space Telescope, JWST, sets its sights on the TRAPPIST-1 system, an intriguing ensemble of 7 Earth-sized planets orbiting a serene red dwarf star, located a mere 40 light-years from Earth. This stellar system, a focal point in our quest to understand the universe's mysteries, presents a unique opportunity for scientific discovery. Among these celestial bodies, 3 lie within the so-called habitable zone, where conditions might be just right for liquid water to exist, raising the tantalizing possibility of life. The TRAPPIST-1 system's allure lies not only in its potential for harboring water, but also in the nature of its central star. Despite its relatively small and cold disposition compared to our Sun, the red dwarf star illuminates these planets with a light not so different from the warmth we feel on Earth, creating an environment where life as we know it could theoretically thrive. Future observations and challenges. Peering into the cosmos, the James Webb Space Telescope, JWST, faces a formidable challenge as it turns its gaze towards Proxima b, a planet orbiting our nearest stellar neighbor in an embrace so close it challenges our conventional understanding of habitability. Locked in a celestial dance just 4.25 light-years away, Proxima b presents a tantalizing enigma, veiled not only by the vast distances separating us but by the inherent difficulties of its observation. The planet's tight orbit subjects it to intense stellar flares from Proxima Centauri, complicating our ability to capture clear snapshots of this alien world. These flares, capable of distorting and obfuscating the signals we so desperately seek, represent significant hurdles to uncovering the planet's secrets. Yet in this cosmic quest, JWST's advanced infrared capabilities emerge as a beacon of hope. Armed with the ability to detect the faint glimmer of city lights or the subtle whisper of an atmosphere, the telescope stands as humanity's sentinel at the edge of the unknown. As it sifts through the starlight, JWST's observations could unravel the atmospheric composition of Proxima b, offering clues to its habitability and the potential presence of life. Potential for future discoveries. As the James Webb Space Telescope, JWST, sifts through the cosmic dust, uncovering the faint glimmers of distant worlds, our quest for understanding the universe and our place within it reaches new heights. The anticipation of future telescopes, far more powerful than those we wield today, holds the promise of peeling back the layers of mystery that cloak our cosmic neighbors. These technological marvels, such as the extremely large telescope, slated for operation in the mid-2020s, are expected to conduct thorough atmospheric investigations, potentially detecting the subtle fingerprints of life across the vast expanse of space. The ability to discern ozone and other key markers in the atmospheres of exoplanets could offer compelling evidence of habitability or even the presence of life itself. This pursuit, driven by a blend of curiosity and existential inquiry, stands at the precipice of profound discoveries. The philosophical and psychological ramifications of such findings are monumental, forcing us to confront the reality that we may not be alone or, conversely, highlighting our unique and solitary position in the universe. What do you think about this? We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.
For centuries, our gaze has been drawn upwards to the mysteries of the cosmos, pondering what lies beyond the glittering veil of stars. Today, the James Webb Space Telescope, JWST, stands at the helm of cosmic exploration, ushering us into a new era of discovery. This marvel of technology, equipped with the most advanced instruments, is poised to unravel the secrets of the universe. But what have these new eyes in the sky revealed? How might these groundbreaking discoveries reshape our understanding of the cosmos? Join us as we delve into the revelations of the James Webb Space Telescope and ponder the profound questions they raise about our place in the universe. The James Webb Space Telescope, often referred to simply as JWST, represents a significant leap forward in our ability to observe the cosmos. Launched in December 2021, this telescope is often hailed as the successor to the iconic Hubble Space Telescope. While Hubble has served us incredibly well, JWST is designed to surpass its predecessor with a suite of advanced technologies and instruments. Equipped with a large primary mirror that spans 6.5 meters across, considerably larger than Hubble's 2.4 meters, JWST can collect more light and observe objects in far greater detail. This larger size allows it to look deeper into space and further back in time, giving astronomers a clearer view of the early universe. One of JWST's most notable advancements is its ability to observe primarily in the infrared spectrum. This capability is crucial because it allows the telescope to see through cosmic dust clouds that obscure other wavelengths of light. By doing so, JWST can reveal hidden regions of space and provide new insights into the formation of stars, galaxies, and planetary systems. The mission objectives of JWST are broad, yet profoundly significant. They include unraveling the mysteries of our solar system, exploring distant worlds around other stars, and probing the mysterious structures and origins of our universe and our place within it. Each of these objectives not only sets the stage for a deeper understanding of the cosmos, but also ensures JWST's role as a cornerstone of astronomical research for the foreseeable future. Now let's dive into the concept of the observable universe and what that really means for us on Earth. The observable universe includes everything that we can see from our vantage point here on Earth, whether through the naked eye or with the most advanced telescopes like the James Webb Space Telescope. It's important to note that when we talk about the observable universe, we're really talking about the portion of the universe from which light has had enough time to reach us since the beginning of the cosmic timeline, the Big Bang, which happened about 13.8 billion years ago. This brings us to the mind-boggling scale of the observable universe. It measures about 93 billion light-years in diameter. Now, a light-year isn't a measure of time, but of distance. It represents the distance that light can travel in 1 year, which is approximately 5.88 trillion miles, or about 9.46 trillion kilometers. To put this in perspective, imagine light traveling at about 670 million mph, which is roughly the speed of light, and covering that enormous distance in a year. So when we say the observable universe is 93 billion light-years across, we're saying that it spans a distance of about 546.84 billion trillion miles, or 878.58 billion trillion kilometers. This immense scale helps us grasp just how vast the cosmos really is, filled with galaxies, stars, and other celestial phenomena, each of which could hold countless mysteries waiting to be uncovered. In the early 20th century, our understanding of the universe underwent a dramatic transformation thanks to Albert Einstein and Edwin Hubble. In 1915, Einstein introduced his theory of general relativity, which radically changed how we understand gravity. Unlike Newton's view of gravity as a force acting at a distance, Einstein described it as the effect of curvature of space-time caused by mass and energy. This groundbreaking theory led to the realization that the universe isn't static but is, in fact, in motion. This theoretical framework set the stage for a pivotal observation by Edwin Hubble in 1929. Hubble discovered that galaxies are moving away from us, and crucially, the farther a galaxy is, the faster it appears to be receding. This phenomenon indicated that the universe is expanding, a concept that was initially counterintuitive even to Einstein. The tool central to understanding this expansion is the concept of redshift. Redshift occurs because as the universe expands, the light from distant galaxies is stretched along with the space through which it travels. This stretching shifts the light towards the red end of the spectrum, hence the name redshift. By measuring how much the light from a galaxy has been redshifted, astronomers can determine how fast it is moving away from us. This not only confirms the expansion of the universe, but also helps in estimating the rate of that expansion. Through these observations, redshift has become a fundamental aspect of cosmological research, allowing us to peer back into the universe's history and better understand its dynamic nature. As we gaze into the cosmos, one of the most intriguing questions we encounter is, what lies at the edge of the observable universe? The observable universe includes everything we can see from Earth, measuring out to about 93 billion light-years in diameter. But what exists beyond this boundary? Theories about the universe's edge often delve into complex and fascinating ideas about the nature of the cosmos itself. One popular theory suggests that the universe might be infinite. If this is true, it means there is no actual edge in the way we might traditionally imagine. Space could extend endlessly, containing an infinite number of galaxies and celestial phenomena, all interwoven in the fabric of the cosmos. Alternatively, some theorists propose that the universe is finite but without any edges or boundaries. This model suggests that space curves back on itself, much like the surface of a sphere. In this scenario, if you could travel far enough in one direction, you might eventually return to your starting point, traversing the universe much like circumnavigating the globe. This concept challenges our perceptions and highlights the extraordinary complexity and beauty of the universe. Both theories showcase human curiosity and our pursuit of understanding the universe's vast scale and form, providing a framework to explore the cosmos further with advanced technologies like the James Webb Space Telescope. The James Webb Space Telescope has once again turned our understanding of the cosmos on its head with its latest discoveries. Among the most startling revelations are the observations of 6 massive galaxies that existed surprisingly early in the universe's history, between 500 million and 700 million years after the Big Bang. Prior to these findings, scientists expected this era to contain only small, fledgling galaxies. The existence of such large galaxies so soon after the Big Bang poses a significant challenge to our existing models of galaxy formation. These galaxies, each comparable in mass to our 13-billion-year-old Milky Way, contain mature red stars, suggesting that they developed far more rapidly than any models had predicted. This rapid maturity contradicts previous assumptions that galaxies in the early universe started as small conglomerations of stars and dust, which gradually grew over billions of years. The James Webb Space Telescope, through its deep-field imaging capabilities, not only captured these galaxies, but provided data that has left astronomers reeling. These findings compel astronomers to revisit and possibly revise our understanding of cosmic history, particularly how galaxies and structures came into being so shortly after the universe's birth. This breakthrough demonstrates the JWST's unmatched capacity to expand our understanding of the early universe, adding depth to our knowledge of galaxy formation and challenging existing scientific theories. The James Webb Space Telescope, JWST, represents a significant leap forward in astronomical technology, equipped with state-of-the-art instruments designed to peer deeper into the cosmos than ever before. Among its most notable features is its suite of infrared capabilities, which allow it to observe the universe in wavelengths of light invisible to the human eye. This is crucial because infrared light can penetrate cosmic dust clouds that often obscure other forms of radiation. One of JWST's primary tools is its powerful infrared cameras. These cameras are essential for observing the early universe, as they capture images of celestial objects whose light has been stretched into the infrared spectrum by the expanding universe. This stretching, known as redshift, is more pronounced in objects that are farther away, meaning that JWST's infrared cameras can see further back in time than those of any previous telescope. In addition to its cameras, JWST is equipped with spectrographs that add another layer of observational power. Spectrographs are instruments that split incoming light into its component colors or wavelengths. This allows astronomers to analyze the properties of that light, including its composition, temperature, and motion. By studying the spectral lines in these light signatures, scientists can determine the chemical composition of distant stars and galaxies, uncovering details about their age, mass, and even potential for planets. Moreover, the telescope's use of coronagraphs, a technology designed to block out the blinding light of stars, enables the direct observation of nearby exoplanets and other faint objects around those stars. This combination of advanced instruments makes JWST uniquely capable of studying the formation and evolution of stars, galaxies, and planetary systems, providing a window into processes that occurred billions of years ago, only a few 100 million years after the Big Bang. In a recent groundbreaking discovery by the James Webb Space Telescope, astronomers have uncovered evidence of 6 massive galaxies that existed surprisingly early in the universe's history, between 500 million and 700 million years after the Big Bang. This revelation is particularly startling because prior to this, scientists had only expected to find small, nascent galaxies at such an early stage in cosmic history. The presence of these large, mature galaxies so soon after the Big Bang poses significant challenges to our existing theories of how galaxies form and evolve. Traditionally, astronomers believed that galaxies started small and gradually grew larger over billions of years through processes such as star formation and mergers with other galaxies. However, the discovery of these universe-breaker galaxies, as they have been aptly nicknamed, suggests that galaxy formation might occur more rapidly and differently than previously thought. Each of these galaxies appears to be as large and as mature as our own Milky Way, which is roughly 13 billion years old. This unexpected maturity of galaxies and what can be considered the cosmic dawn forces astronomers to reconsider the physics of early universe galaxy formation. It suggests that significant amounts of star formation must have happened very quickly to allow these galaxies to reach such a mature state so early on. These findings not only raise questions about the speed and process of galaxy formation, but also hint at the possibility that the conditions in the early universe might have been different from what the current models suggest. Now let's look at what the future holds. As we continue to push the boundaries of our cosmic knowledge, the future of space exploration looks brighter than ever, thanks to upcoming missions and advanced telescopes. A particularly exciting development is the planned launch of the Nancy Grace Roman Space Telescope, formerly known as the Wide Field Infrared Survey Telescope, or WFIRST. Scheduled for launch in 2027, this telescope will carry on the legacy of the James Webb Space Telescope by delving even deeper into the mysteries of the cosmos. The Roman Space Telescope is designed to explore various fundamental questions in the fields of dark energy, exoplanets, and infrared astrophysics. With a primary mirror diameter of 2.4 meters, identical to that of the Hubble Space Telescope, the Roman Space Telescope will offer a new perspective on the universe. Its wide field instrument will allow it to capture images over a field of view more than 100 times larger than that of the Hubble, enabling it to survey the sky at unprecedented scales. This will not only increase our ability to observe the cosmos, but will also dramatically enhance our understanding of the universe's structure and evolution. Moreover, the Roman Space Telescope will be equipped with a coronagraph instrument, which is specifically designed for high-contrast imaging and spectroscopy of nearby exoplanets. This instrument will be crucial for blocking out the overwhelming glare of stars, allowing the telescope to directly image exoplanets. Such capabilities are expected to revolutionize our insights into planetary formation and offer new possibilities for studying potentially habitable planets. By building on the discoveries made by the JWST, the Roman Space Telescope will extend our cosmic reach, bringing us closer to answering some of the most profound questions about our universe. This seamless integration of past achievements with future potential underscores the dynamic and ever-evolving nature of astronomical exploration. In summary, the advent of the Nancy Grace Roman Space Telescope marks a significant milestone in our ongoing quest to understand the cosmos. By leveraging cutting-edge technology and building upon the foundation laid by the James Webb Space Telescope, this new mission promises to expand our horizons further, offering deeper insights into the universe's secrets and potentially uncovering new realms of knowledge in dark energy, exoplanets, and beyond. As we look to the future, the potential for discovery seems limitless, promising a new era of astronomical breakthroughs. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.